Right, so today we'll concentrate on database. First, we want to finish the database design process. We want to finish that. So then we want to do the data normalization as well. Okay. So that is again design topic. Though it is your last topic in syllabus, we will do it before proceed to the other part because it's anyway related to designing. Okay. Right. So last time we start discussing database designing process. Remember, the input to the database design process is your conceptual ER, which is done at the analysis. Okay. Right. So what are the basic ideas behind design? A good design. So we want to make sure that we minimize the data redundancy. That means data is not unnecessarily duplicate. We can't make it zero because to relate tables anyway we need foreign keys, but we try to minimize, right? Minimize. So that is our first objective. Then also we want to enforce the data integrities. So that means data is always related. So there are no isolated data. And of course, other than those, we need to think about security, performance, and so on as well. Right. So then we discuss how to design a database. First, we do the logical design. So then we do the physical design. So logical design is we are not committed to a particular database system, like whether we have not decided whether it's Oracle or MySQL or Microsoft SQL, but we have committed whether we use relational databases or object databases or that kind of a thing is done. Okay. So therefore, once you do logical designing, assuming it's relational database, so we can pick and choose whether we go for Oracle or MySQL or Microsoft SQL and do slight changes in the physical design. Okay, so that is the idea. So we go step by step, okay? Right, so then we discuss some terminology, right? So attributes become fields or columns, relations become tables, okay? So then we discuss what is tuple or record. We discuss what is attribute domain, possible values for a particular field, cardinality of a domain, right? How many possible values are there? Sometimes cardinality is infinite. Sometimes there are fixed number of possible values like gender, like male, female, right? Like results, maybe pass and fail, maybe A, B, C, F. So then we look at what is degree of a relation, that is number of attributes or number of fields in a relation or table. And then cardinality of a relation is number of records. Of course, when you do insert, updates, delete, those things get change. Then we look at what is null value is. So if a particular field having no value, not assigned for a particular record, so then we say that it is assigned null value. Okay, so null is not a string null, it's just a conceptually we say null. And when you write SQL also, we use the concept null. Is null, is not null. So then we look at what is the concept behind primary key, right? What is candidate key, what is primary key, what is alternate key, what is a super key, and two type of primary keys, simple primary key versus composite primary key, and domain primary key versus surrogated primary key. Okay, right. So we discuss these things. I'm just going through it. Okay. So then we look at what are the features of good primary key, which we will further discuss today under normalization. So then we look at some design ideas. When you design your tables, so if you have a derived attribute, so don't include a field for that because we can derive it from other stored attribute. So if you have composite attributes, make sure you have fields for the sub attributes, not for the composite attribute, right? So you don't have address field, rather you will have number, street, and city 3 fields, right, in your database. So if it is a multi-valued attribute, so you need to introduce a new table and map it as one-to-many relationship. Okay, so that is another aspect. Right. So then we discuss how to create relationships. So we create relationships using foreign key. So what is a foreign key? Foreign key is a field in a table which is mapped to the primary key of the related table. Right. For example, department ID is a foreign key because it's a field in a table which is mapped to the primary key of the maybe department table. So it's in employee table, it's a foreign key. So in relational databases, always your relational field is mapped to the primary key, not to any other field. Okay. Again, your foreign key can be simple key or composite key. Because related table, if you have a composite key, of course, your foreign key can also be a composite. So then we look at the degree of relationship and cardinality of a relationship or multiplicity of a relationship. So unary, binary, ternary, right? Quaternary, n-ary. So then multiplicity or the cardinality can be one to many, one to one, one to many to many. So we did some examples, right? Using access, we created some relationships. I think I shared you the database also. How to design one-to-one relationship at the foreign key to the many side. Okay, at the foreign key to the many side. Like this. One department, many employee. One employee belong to one department. So if it is unary one-to-many, of course, you need to add the foreign key to the same table. I think we did not discuss unary relationships last time. Right. So this is what we did last time. So we had one-to-many relationship between employee and department. We had one-to-one relationship between employee and spouse. And how to do that? You make the foreign key to the weak table and make it unique. One-to-many, of course, you add the foreign key to the many side. When it comes to many-to-many, what we did? We need to add a connecting table and create it as two one-to-many relationships. And therefore, many side is a connecting table. So it is going to have two foreign keys. And the combination of those two foreign keys can be the primary key, or you can go for a surrogated key. So do you have any questions about that? Because we did it about 4 weeks ago. Because this is super critical. Right? Sometimes students, even in the final year, they don't know how to decide. I don't know why. Sometimes I don't know why they are doing final year. They should have dropped out of the BIT course. If they don't know how to design one-to-one relationship, one-to-many relationship, many-to-many relationship. Right. So do you have any questions about these things? Any doubt? එහෙම doubts උත් මොකුත් නැත්තම් final year ගියාම project එක කරගෙන යන්න එපා. කරගන්න නැතුව මොකටද ඉන්නේ මේ සුද්ධ සිංහලෙන් කිව්වොත් නිකන් කාලා කන්නේ වගේ. මේ දවස්වල ඒවා clarify කරගන්න එපා. final year කියන්න කලින්. final year ගියාට පස්සේ project class වෙන සල්ලි ගෙවක. සල්ලි ගෙවක project class නැද්ද? නැත්නම් සල්ලි ගෙවලා ගන්න project නැද්ද? හරි මහා තක්කඩි ඉන්නේ. කාලා ගන්නේ 60. සල්ලි ගෙවලා project අරගෙන university එකට දෙන්න මොන මගුලටද degree එකක් කරේ? විලිලැජ් නැති කමක්ද නේද? ෆයිනල් ඉයර් ගිහිල්ලා ඉවල ප්‍රොජෙක්ට් ක්ලාස් යනවා කියන්නේ තව ක්ලාස් ඉල්ලනවා ප්‍රොජෙක්ට් ක්ලාස්. ඊට පස්සේ ආයි ජොබ් ක්ලාස් නැද්ද කියලා. මට ඉන්ටර්විව් ක්ලාස් නැද්ද? ජොබ් ක්ලාස් නැද්ද? හරි ඊට පස්සේ කී ආයි අර මේ දේශපාලකයන්ට පස්සපැත්ත දෙන ක්ලාස් නැද්ද? මොන ජීවිතද? ඒ වගේ ජීවිත වලට යන්න එපා. ප්‍රශ්න දිනන ටක් ගාලා විශ්සගෙන ෆයිනල් ඉයර් කියලා ප්‍රොජෙක්ට් එක කරනවා, ජොබ් එකට ඉන්ටර්විව් දානවා, ජොබ් එකට යනවා. මිනිස්සුયો. Right. So in one-to-one, what happens? So one record in X table is related to one record in Y table. Say one employee have one spouse. Right. One spouse is belonging to one employee. I hope that you can understand. So then how to model it? If it is strong entity and weak entity, add the foreign key to the weak side. If it is between two strong entities, you can add the foreign key to any of the side. So in this case, the weak entity is spouse. So therefore, we add the foreign key to the spouse table. So foreign key is the primary key of the related table. So related table is employee. Its primary key is employee ID. So therefore, we added employee ID as the foreign key. We just add that column and map it to the primary key. We drag and drop it here. So then effectively, you can see that even Access has understand that, okay, it's a one-to-one relationship. Okay, you can see Access has understood, identify that it's one-to-one. Now, when you insert data, so obviously, when you insert spouses, one spouse can be connected to only one employee. For example, let's do it in a table level. So this is my spouse 3, already connected to employee 4. Now I can't connect my spouse 3 into any other employee. Or two employees cannot be connected to the same spouse. For example, employee 1 is connected to spouse 1. Now I can't connect employee 1 to spouse 3. If I try to save this, I will get error. You can see, you get error. So that is because it's one-to-one. But that was not the case when we had employees. So different employees we connected to the same department because we never made this field unique. But here employee ID field is a unique field. Okay, unique field. So therefore you can't save any same value twice. So remember when we do it with the design view, right, design view. So we made employee ID. You can see here index, yes, no duplicate. So no duplicate means unique. So in normal one-to-one relationship, we don't make it no duplicate. We just say, yes, duplicate allowed. But so that is what we did in the employee table. Employee table also we had a foreign key, but there you can see yes, duplicate okay. But in spouse table, it is yes, duplicate not allowed, not okay. So that is the difference with that make it one-to-one, not one-to-many. Okay. So that is how you make one-to-one relationship. Okay, right. Right. So all those relationships we made were binary relationships between employee and spouse, employee and department, employee and project, two entities. So there is a possibility of creating relationships within the same entity. So then we call it unary relationship. It can be unary one-to-one, unary one-to-many, unary many-to-many. And there's a possibility of creating relationship between three entities. So then it's a ternary relationship. And of course, there's a possibility of creating relationship between four entities. Then it's a quaternary and so on. But when you design software, more than 80% of the time, or almost 90% of the time, or maybe 80%, those are binary relationships. Maybe about 5% of the time, there's a possibility of unary relationship. Maybe another about 4% ternary relationship. Very rarely you get quaternary or above. Almost, actually in my career, I have never seen quaternary relationship. Someone has designed a quaternary relationship, but I have seen ternary relationships. But 90% of the binary. And sometimes, yes, unary relationships are there. Now you should be able to think of a scenario and design a database. Say order processing system, student management system, right? Banking system. So that is your outcome. So if you can do it, then you can say that, yes, I have done wonderful thing in my semester 2. I have done my database. Now I have learned my database subject. So if you think of a scenario and send me the design, I will always review it. ඒ වගේ ඉගෙන ගන්න අයට අපි 100% උදව් කරනවා. 100% නෙවෙයි 200ක් උදව් කරනවා ඉගෙන ගන්න අයට. මොකද අපි දන්නවා මේක ඉගෙන ගන්නවා මේක ඉස්සරහට වැඩක් කරනවා. So the final year project also the same. කොටසක් ඉන්නවා project එක ඇත්තට කරනවා මහන්සි වෙලා. එලකිරි. තව කට්ටියක් ඉන්නවා මහ ගොන්තැබ්බවල නැත්තම් කාලකන්ණි හැත්තා. බොරු කරනවා. බොරුවට කරනවා කියලා පෙන්නනවා අන්තිමට වෙන කාගේ හරි project එකක් පෙන්නනවා. කාගේ හරි project එකක් අරන් ඇවිල්ලා ඒක අපි වන්දන්නම්කෝ අපි තුම්පණෙන් ඇවිල්ලා නැහැනේ අපි හරක් නෙමෙයිනේ. දැක්ක ගමන් තේරෙනවා මේ බොරුව කරන්නේ කියලා. අනුන්ගේ ප්‍රොජෙක්ට් කෑල්ලක් අරගෙන බොරුවට අන්තිම දවසට ඒක පෙන්නනවා. වචන දෙකක් කතා කරාම තේරෙනවා තමන් කරපු දෙයක්ද බොරු වෙන කාගේ හරි එකක්ද කියලා. ඒතකොට ඩිග්‍රියක් හරි මොනවා හරි දෙන්න ඕන අර ඔරිජිනල් ප්‍රොජෙක්ට් එක හදපු මනුස්සයා. අන්න එලෙක් මනුස්සයා. එයානේ කළා තියෙන්නේ මෙයා නෙමෙයි නේද අන්තිමට. එයා කොහෙද මොනවද ඉගෙන ගත්තේ? මිනිහට ඩිග්‍රියක් නැද්ද? නැත්නම් මිනිහට ඩිග්‍රිය දෙන්න ඕන ඊට කලින් ගිහිල්ලා. කලින් නෙමෙයි මේකට නොදී. Right. So when it comes to unit relationship, you know that the relationship is between instance of the same object, same entity, same table. Right. So that is what is meant by unary relationship. Okay. So again, the concept is the same. Right. You can create one-to-one relationship, one-to-many relationship, many-to-many relationship. Okay. Right. So we'll use a different database because otherwise your ER diagram will become right very complicated. Right. Not very complicated, but because scenarios that we will take for the unary relationships are different. Okay. So therefore I'll create a new database. ඔයගොල්ලෝ කැමති අය දැම්ම මේත් එක්කම කරන්න පුළුවන්. කැමති අය හරි කැමති බොරු ගහ කරන අයට ඕනේ නැහැ කරන්න. Right. I'll save it as for the three scenarios like unary, sorry, not, yeah, unary one-to-one, one-to-many, many-to-many. I will take three isolated scenarios. Those are not connected. Like previous example, those are connected. Spouse is connected to employee, employee is connected to the project, employee is connected to department. It's just sort of a one database. But for this one, I will be using one database, but I will be using three separate isolated cases. Okay. So this one is for unary one-to-one. Sorry, unary one-to-many. So this is the scenario we want to design. Okay. So let's assume we have student. And student, okay, not student. Let's case something like one-to-many. Yeah, employee and supervisor. So let's assume an employee can have maximum one supervisor. That supervisor is also an employee. Okay. And one supervisor can supervise many employees. So that means one supervisor can supervise many other employees. Of course, supervisor is also an employee. Okay. But if you take one employee, he must be supervised by only one supervisor. So therefore, there can be another supervisor. Let's use black for the supervisors. Maybe that supervisor is supervising maybe some other employees. But these are also employees. Maybe this supervisor is supervised by another employee. එයාට supervisor කෙනෙක් ඉන්නවා. Maybe these two are supervised by these two. You can see it's a one-to-many relationship. One can supervise many. But someone is supervised by only one person. That means one can have many under that person, but person has only one supervisor. And supervisor is also employee. So therefore, it's the relationship between employees. And it's a one-to-many relationship. One-to-many relationship. එහෙම තේරෙන්නේ නැත්නම් ඒ වෙලේ අහන්න මම දන්නේ ඔයගොල්ලෝ ඒ කතා බහ කරන්නේ නැති කියලා හරි. හරි ප්‍රශ්නයක් මේක. හරි. එහෙනම් මෙහෙම කතා බහ කරන්නේ නැත්නම් මට 100% තේරෙලා තියෙනවා. හරි. කතා බහ තේරෙලා නැති කට්ටිය කතා බහ කරලා විස ගන්නවා. ඔච්චරනේ කතන්දරේ නේද? එක්ක තේරෙලා තියෙනවා නැත්නම් ඔයාලට ප්‍රශ්න තියෙනවා. ඒ ප්‍රශ්න කතා බහ කරනවා මේ විදිහට. ওই දෙක අතර වෙන්න බෑනේ. තේරෙලත් නැහැ මට ප්‍රශ්නත් නැහැ. එතකොට මොකද්ද එතන වෙන්නේ එතකොට නේද? එහෙම වෙන්න බෑනේ. එහෙම වෙනවා කියන්නේ මහ වැඩ. තේරුම් නැති වැඩක් එතන වෙන්නේ. හරි. Right. So now I hope you can understand the scenario. Right. So it's a relationship between employees. And there's a relationship between employees. So therefore there's a relationship. And it's a one-to-many. So therefore foreign key must be added to the many side. So many side is also employee. So therefore we are going to add the foreign key to the employee table itself. Right. So that means your employee table has a primary key and foreign key, which is referring to the primary key of the same table itself. Because there's a unary or recursive one-to-many relationship. Okay. මේක තේරෙන්නේ නැත්නම් අහන්න ඕන. එතකොට මට ආයෙ එක්ස්ප්ලেইন කරන්න පුළුවන්. මට ඕන තරම් වෙලා අරගෙන එක්ස්ප්ලেইন කරන්න පුළුවන්. හරි. ඕන තරම් එක්ස්ට්‍රා ක්ලාස් දාන්න පුළුවන්. කිසි ප්‍රශ්නයක් නැහැ. ඉගෙන ගන්න කට්ටියක් ඉන්නවා. බොරු කරන අයට එක්ස්ට්‍රා ක්ලාස් දාලා තවත් බොරුවක් නේද? So I call it employee. Right. I'll call this employee ID. We'll use auto number, say e-name, and maybe salary. And employee ID is the primary key. Now I need to create that relationship. Right. Remember, employee can have supervisor. So therefore, now we need to add the foreign key. Now, so far what we did is, when there's a relationship between employee and department, we add department ID to the employee. Okay, because department ID is the primary key of the other table. But in this case, I need to add a foreign key, but its primary key is in the same table. So therefore, if I add again employee ID, you can't, because sorry, you can't have two fields with the same name. Okay, so if you go by that convention, my foreign key name must also be employee ID, because the name of the primary key. Of course, that is a convention, but this time I can't follow that convention because you can't have two fields with the same name. So employee ID field is already there. So therefore, this time I will break that convention. Anyway, it's not a rule, convention, and give my foreign key a different name, which is different from the primary key of the related table. In this case, related table is also this table. So therefore, I'll call it supervisor ID. Okay. And its data type must be compatible with auto number. So therefore, I'll make it number. Okay. Yeah, student of a class and leader. Yeah, correct. It's a unary. I don't know now. Still, do they use that concept, leader? Leader කියන concept එක දැන් පාවිච්චි කරන්නේ නැහැ නේද? Monitors හදාන්නේ නැහැ නේද ඉස්කෝලවල? මම දැන් තාම දානවාද කියලා. Anyway, එහෙම ඉස්කෝලවල තාම ඉන්නවනම් monitorsලා නැත්නම් leadersලා, yes, it's a unary one to many. Okay, unary one to many. But it can be designed using some other ways also. Because then that monitor or leader can be connected to the class. Because there's a well-defined structure there. Class. Class එකකට දාන්නේ. Student ලට නෙමෙයි අතන දාන්නේ class එකට දාන්නේ. මම දන්නේ class එකට නැතුව දානවා නම් තමයි අපිට ওই විදිහට කරන්න වෙන්නේ. random පොදුවේ. හරි. Right. So I'll call it supervisor ID and I want to make this my foreign key. Okay. I want to make this my foreign key which is mapped to the employee ID. So there's a small limitation when it comes to design or not in the development, the relationship view of the access database. So therefore, when I model this, I can't model like this. So I will not be able to model in the ER diagram. I cannot model it like this because access doesn't allow this. So therefore, I need to create a copy of the same table and make it looks like binary, but in reality, it is not binary, it is a unary. Okay, so that is only in access there's an issue, but in other databases, you can even model it like this. Okay, like MySQL. Right, so now I will go to the relationship view. I will add employee. I will add employee again because, for example, if I try to drag and drop my supervisor ID to the employee ID, it doesn't work. You can see it doesn't allow. So employee ID into supervisor ID is not allowed. So that is a limitation in access. So therefore, I can't visually show the relationship like this because access has that limitation. Okay. So therefore, when it comes to access this relationship view, what I have to do is again add a copy of employee, but okay. But this is the same table. This is the same table. So therefore, you can think of it like the same table, okay? Though visually like this. And now I can add employee ID and drop it to this. Its copy is supervisor ID. Now it says enforced referential integrity and it knows it's one-to-many. Right? But remember, you need to understand it like this, okay? Because both are the same table. It's just the access doesn't allow you to drag it onto itself. So therefore, I had to create a copy. Right? But this is also employee table. This is also employee table. So therefore, you can think of it like this. Right? Think of it like this. Though we draw it like this. Okay. That is due to some limitations in access relationship view. Now I have created one-to-many, unary one-to-many relationship. Let's close it. And if you want now, we can add some data also. Say Nimal, salary is 100,000. And assume Nimal doesn't have supervisor. Okay, Nimal doesn't have supervisor. So what about Kamal? Say 120,000. And let's assume Kamal also doesn't have supervisor. Maybe Chamal. Say 90,000. Let's say Chamal supervisor is Kamal. Okay, so let's say Vimal. Let's say Vimal salary is 75,000. And let's say Vimal supervisor is also Kamal. Remember, this is unary one-to-many. Okay. So let's say we have Amal with 85,000. Maybe Amal supervisor is Nimal. Now you can see that our data has one-to-many relationship, but unary one-to-many. Unary one-to-many. Okay. So therefore, an employee can have maximum one supervisor. But same supervisor can be supervising more than one employee. In this case, you can see that Kamal is supervising both Chamal and Vimal. Okay. So that confirm that it is one-to-many. So this is one-to-many unary or recursive relationship. This is how you do it. Right? You add the foreign key to the same table and map it to the primary key of that table. So just we name it different name because you can't have two fields with the same name. So we just name it supervisor ID and made it my foreign key. And that foreign key has mapped to the primary key or this same table's primary key. Again, batch coordinator, you don't need one-to-many unary relationship because there's a concept called batch there. There's a concept called batch there. ඔයගොල්ලෝ දෙන උදාහරණ එකක්වත් මම මේ කියන කතන්දරේ අවශ්‍ය නැහැ අතන. Because then what happens is you have batch. Right? You have batch. Batch or batches or whatever batch. The 2024 batch, 2025 batch, you have the records at it. So then you have the batch students. One-to-many. One batch has many students. Okay. So then you can have maybe another relationship between batch and student. So that is another field like, I don't know which name you use, batch representative or batch lead or whatever. සාමාන්‍ය අපි යන කාලේ කිව්වේ batch representative කියලා. batch leaders ලා දැම්මේ නැහැ. මේ batch leader කෙනෙක් කොහොමද කවුරුත් තීරණය කරන්නේ? එහෙනම් batch leaders ලා ඉන්නවද යුනිවර්සිටි වල batch වල? Sorry, all right, batch coordinator, yes. Yeah, that is correct. Yeah, batch coordinator. So batch coordinator කියලා කාවර එක්කෙනෙක්ව දාගන්න. Right, brought batch leader. Batch නෙමෙයි අර කලින් එකේ දැන් leader කෙනෙක් ආන්නේ student leader කියලා. Right, so that is then you have the same relationship with the batch rather than students are mapped because students are already in a batch. Student ලා already batch එකක ඉන්නේ දැන්. එතකොට student ලා map කරන්න ඕනේ නැහැ එහෙම recursive විදියට. ඒ වගේ තැන් වලදී අපිට පුළුවන් ඒ batch leader map කරන්න batch එකට. So that is easier. That is better actually. Okay. So therefore the both maybe the previous example is okay. Student and student leader. හැබැයි ආයිමත් පන්තියට එක්කලා ගන්න නම් ඉන්නේ ආයෙ ඕනේ නැහැ. හරි. පන්තියට එක්කලා ගන්න නම් ඕනේ ඕනේ. හැබැයි supervisors ලා එහෙම නෙමෙයි. හරි. supervisors ලා එහෙම නෙමෙයි. ඒක වෙන කතන්දරයක්. ඒ වගේ කතන්දර වලට අපිට මේක ඕන වෙන්නේ one to many unary. One to many unary. Okay. Right. So if you don't have any question, now can you think of another unary one-to-many relationship? Unary one-to-many relationship. මට මේ database subject එකට ඕන තරම් වෙලා ගන්න පුළුවන්. හරි? මොකද මේක තමයි වැදගත්ම subject එක. හරි? semester 1 වල programming subject එක, semester 2 වල database subject එක. මේ subject එක හරියට ඉගෙන ගත්ත කෙනෙක් විභාග පාස් වෙනවා කියන එක නෙමෙයි. හරියට ඉගෙන ගත්ත කෙනෙක් ඊළඟට semester 2 වල web development subject එක, semester 3 වල web development subject එක, අන්න final year project එක කරනවා. job එකකට ගිහිල්ලා software develop කරනවා. හරි? whatever ඒ වැඩ කරනවා. ඒවා තේරෙන්නේ නැති කට්ටිය බොරු තමයි ඉතින්. හරි. ඩිග්‍රියක් ගන්නවා නමුත් software එකක් develop කරන්න බෑ ඒගොල්ලන්ට. හරි වෙන මොනවා හරි කරගන්න පුළුවන් නම් කරගන්න. Can someone tell me another example? වැරදුනට කවන්නේ නැහැ. ඉතින් හරි වැරදුනොත් මම කියන්නේ මේක මීට වැඩිය මෙහෙමත් කරන්න පුළුවන් කියලා. දැන් මම කිව්වා batch එකේ කතන්දරේ. University batch එකේ. Unary one to one relationship එකක් හැදෙන්න පුළුවන් අවස්ථාව. supervisor manager ඔය කතන්දර වලින් එළියෙන් යද්දන් කියනවා. මම කිව්වා unary relationship හරි අඩුයි. ඉතින් එකපාරට හිතන්න බෑ තමයි මම දන්නවා. සවා හිතන එක සමහරට බොහෝ විට වරදින්නත් ඉඩ තියෙනවා. ඒ මොකද senior boys having relationship junior boy කියන්නේ. එහෙම database වලට ඕනේ නේද අපිට senior boys like senior එහෙම database හදන්න ඕන වේද අපිට කවදා හරි ජීවිතේ I don't think right I don't think that we need to create database එහෙම relationship තියාගත්ත කියලා කවුරුත් database හදන්නේ නැහැ නේද මෙයාත් එක්ක මෙයාගේ relationship එකක් තියෙනවා කියලා එතකොට හරියට නිකන් අර මොකද්ද මේ ඕපදූපයක් වගේ නෑ නේද එහෙම වුණොත් ඒ gossip relation table එකක් තමයි වෙන්නේ gossip table එක think about practical things like official things so I need marriage is one to one නේද one to many marriage තියෙනවද මන් දන්නේ يعني historically නේද සාමාන්‍යයෙන් at a time one marriage එක්කෙනාට one to I need one to many unary student and course කියව ගම unary නෑ නේද දෙකල්ලෙක්නේ student course කියව ගම එක unary නෙමෙයි it's binary so marriage එක ඉතින් one to one නේද president and citizen ඉතින් ඒක අර supervisor වගේම තමයි හැබැයි නේද ඒකයි කතන්දරේ ඔව් theoretically ඔව් citizen have one president has many citizens හැබැයි එතෙන්දිත් අපිට එහෙම කරන්න අවශ්‍ය නැහැ because then we have a concept called country so then we can map president to the country වෙන වෙනම individuals වලට දාන්න නැතුව අපිට පුළුවන් කෙලින්ම country එකට දාන්න so citizens are related to country and president is also related to country කියලා අපිට එතනින් මේක හදන්න පුළුවන් ඊටදී ලේසියි product categories how do you map it එකන එක then product and category are two different things right product and category two different things this one is correct yes category can have subcategory so that is a good example right so category can have subcategory yes that is correct so your category have subcategories okay so that is actually excellent example okay maybe first we have categories like food items right stationery and so on so then maybe food items we have vegetables right and so on milk food so this category is related to this category and this category has many subcategory belong to one parent category so that is superb example so it's likewise you must start thinking එතකොට හරියටම ටක්කටම හරියනවා උදාහරණ එනවා right so now let's look at unary one-to-one relationship unary one-to-one relationship so unary one-to-one relationship is again relationship between instances of the same entity same table or records of same table but those are one-to-one one-to-one okay so the example I gave you is I think we discussed this when it comes to model ER modeling in requirement analysis and modeling the requirements. So student can have a partner student. පොඩි කාලේ දෙන්න ජෝඩු මැප් කරන්නේ නේද? ඔයාගේ යාළුවා මෙයා. ඔයාගේ යාළුවා මෙයා හැමෝටම එක යාළුවෙක් ඉන්නවා. එක්කෙනාට මැප් කරන්න එක්කෙනයි. So then it is unary one-to-one relationship. Or you can say marriages. So these are humans. So one human is married to another human. One human is married to another human. One-to-one. Okay, so those are one-to-one unary one-to-one relationships. Right, so let's do that. So I'll create a table. I'll call it student. Say student ID, photo number, primary key, S name. Let's say that's enough for me. Now I can introduce, because I can't give the same name as student ID for the partner, I will call it partner ID. And it must be a valid number. And we want to make this one the foreign key. And also because we want to make it one-to-one, now you know what to do, make it unique or duplicate not okay. So therefore I'll make partner ID, go down the property, it says yes, duplicate okay. I will say yes, duplicate not okay. Right? No duplicates. Make it unique. Now I can map the foreign key relationship, go to the database tools relationships. Again, I need to drag and drop it 2 times because otherwise access doesn't allow. But remember now partner ID is a unique field. So therefore, when I drag and drop, because I can't drag and drop in the same side, the same table, I had to take the copy of it. And now I will drag and drop it here. And you can see it has identified it as one-to-one because I make that unique or duplicate not okay. I've said enforced referential indeed. So that is unary one-to-one relationship. Right? Unary one-to-one relationship. You have to think it like this. Okay? Because both are the same table, the copy of the same table. So now you can say Nimal. Say, I will add the partner later. Of course, 0 is not there. I will delete it. මම දෙක වගේ නම් දාන්නම්. නිමල් සහ නිමාලි. So then Nimali's partner is Nimal. Nimal's partner is Nimali. Kenet ඉන්න එක partner කෙනෙක්. Say Amal. Amal's partner පස්සේ දාමු. Say Amali. Say Amali's partner is Amal. Amal's partner is Amali. You can see it's one-to-one. Then මේ එක partner ID එක දෙපාරක් දාන්න දෙන්නේ නැහැ. මෙතනට මට උදාහරණෙ දෙක කියලා දාපු ගමන් save කරන්න දෙන්න. Now I can save. But if I add 1, I can't save because it's unique. Because it's unique. Okay. So now I can save. So it's a one-to-one, unary one-to-one relationship. Okay, unary one-to-one relationship. Any questions? Any question about unary one-to-one? Right. So the next we will look at unary many-to-many relationship. Unary many-to-many. M-to-N, but it's unary M-to-N. What is the example we took? Because Facebook හදලා තියෙන ඔය විදියට තමයි. Right. A member can have many friends. Friends are also members. And that friend can have again many friends. මට ෆ්‍රෙන්ඩ්ස් 100ක් ඉන්නවා. ඒ මගේ එක ෆ්‍රෙන්ඩ් කෙනෙක් ගත්තොත් එහෙනම් මට ඒ ෆ්‍රෙන්ඩ්ස් තව 500ක් ඉන්නවා. මට එයා ෆ්‍රෙන්ඩ් වෙද්දි තව අයත් ෆ්‍රෙන්ඩ්ස්ලා. එයාට මම ෆ්‍රෙන්ඩ්ස් වෙන්න එයාට වෙන අයත් ෆ්‍රෙන්ඩ්ස්ලා. many to many. එයාත් Facebook user කෙනෙක් මාත් Facebook user කෙනෙක්. Okay. So let's model that because it's a very famous example. Right. So I will create a table user say user ID photo number primary key and maybe uname. Now I will call it friend ID. Remember this is meant to many, right? So what happens that I forget about that. So what about when you have many to many relationship? There's no way to model it without introducing a connecting table, right? So I forget about that. So therefore, this is, yes, we want to make it many to many, but there's no way you can model it, design it and implement it without introducing another table. එහෙම කරන්න බෑ. දැන් ඔය කරන්න යනකොට තමයි මතක් වෙන්නේ අකෝ මෙහෙම කරාට හරියන්නේ නැහැ නේ කියලා. So therefore, what we need to do? Yes, this is my requirement. The user is mapped to many users. We can call it friend or friendship or whatever. But that is by requirement. Now, when it comes to designing, this union relationship need to be designed like this. You need to introduce a connecting table and model it as one to many here and again one to many here. And this connecting table is connecting to the same table now. And this is your connecting table. And now we have two one-to-many relationship. Okay, so therefore let's add a connecting table. මේ වැඩේ කරන්න බෑනේ මෙහෙම. මට පස්සේ මතක කරන්න යනකොට දැන් මේක හරියන්නේ නැහැ නේද කියලා. Right, now I can save the user. අර connecting table එකට නමක් දෙමු. සාමාන්‍යයෙන් දෙන්න බෑ user_user කියලා. අර employee table වගේ, employee department වගේ, but let's give little bit more meaningful one like friendship. Okay, friendship for some. Right. Now it's going to have two foreign keys, right? It's going to have two foreign keys because it has two one-to-many relationships. Without foreign keys, it basically friend ID. The friend ID is there, you know. Friends are there, IDs there, you know. So therefore, we'll call it friend 1 ID, friend 2 ID. Because friendship again. දෙපැත්තක් තියෙනවා. Friend 1_ID or friend ID 1. Friend 2_ID. නැත්නම් වැඩි හොඳ friend ID 2 කියලා දැම්මා. friend 2 ID කියලා. Now, of course, I am not going for the auto numbers. I will mark it number. Because those must be valid user IDs. Okay. And maybe some common field like date of friendship accept කරපු දවස, right? Type of friendship, okay, let's say date of friendship. Date of friendship. So let's make it date. And now, of course, this combination must be primary key. So therefore, I select both using control key and say primary key. Now you can see it's a composite primary key. Now I need to add map the foreign keys. Okay, map the foreign keys. So I go to the relationships. I will take the user. I will take the friendship. Right. Most probably I will not be able to copy this, drop this twice. Then I may have to create a copy of user again. But anyway, let's double check. I will drag user ID and put it into the friend ID, friend one ID. Yes, it's one-to-one relationship. But I don't know it. I don't think that this is allowed in access. Yes, we can, right? Yeah, no, it says already exists. So therefore, the first one will be deleted. So therefore, what I need to do is again create a copy of this user table. I will drag it again. Okay, drag it again because basically remember this one is also this one is a copy of this one. Say actually you are looking at the same table. Okay, just this view doesn't allow me to drag and drop it again. So now I can again drag and drop it to the second ID. But you need to understand it something like this. Okay, something like this because both are the same. Okay, so both are same. Now we have unary one-to-many relationship. Unary many-to-many relationship between user table with the help of the connecting table called friendship. Okay. Right. Now, of course, I can add some data to the user table like Nimal, Amal, Kamal, Bimal, Jamal, and so on. Okay. Now, how do you show the relation friendship between these guys? That you need to now remember we have user IDs from 1 to 5. In friendship, you can have something like 1 is related with 2, and maybe 1 is related with 3, maybe 2 is related with 2 is related with 3 also, maybe 2 is related with 4, and so on. It's a man-to-man relationship, and of course, date of friendship you can add. කවද්ද මේගොල්ලෝ friends ලා වුනේ මේ system එක ඇතුලේ. System එක ඇතුලේ. Okay. So that is how you do it. So I don't know forms generate කරනකොට නමුත් එච්චර practical විදියට forms generate වෙන්නේ නැහැ මේ unary ඒවට. මොකද යාට ඒක auto generate කරන්න බෑ අපි හදන්න ඕන. අපි නිකමට දාමු මේ user එකට. Say create form. Obvious user ID name විතරයි තියෙන්නේ. Friendship එකට tag ගමු. Create form. මේ දෙන්න අතර friendship එක 1 සහ 2 අතර මේ දවසේ ඇති වුණේ. 1 සහ 3 between 1 and 3 this is the date of friendship. This is between 2 and 3. There's a friendship between 2 and 3. Okay. Right. So that's it about unary relationship. Any idea? Any questions? No තේරෙන තැන් මොනවා හරි තියෙනවද? Ternary relationship ගැන. එක්ක ප්‍රශ්න තියෙනවනේ එක්ක තේරෙන්නේ නැති වෙන්න ඕන. Sorry, එක්ක ප්‍රශ්න තියෙනවනේ එක්ක තේරෙනවා වෙන්න ඕන. තේරෙනවද කියලා බලන්න කොහොමද උදාහරණ දෙන්න පුළුවන් ඕන තරමක්. බය නැතුව definition එක දෙන්න පුළුවන්. කවුරු හරි එකයි ගැන කතා කරන්න බයක් නැහැ. ඒ කියන්නේ ඉන්ටර්විව් යන්න බය නැහැ. දැන් ඔයගොල්ලෝ අහනවානේ මේ BIT ඩිග්‍රියේ තත්ත්වය මොකක්ද කියලා නේද? ඔව් එහෙම එක එක ඩිග්‍රී අතර වෙනස්කම් තියෙනවා. වෙනස්කම් තියෙනවා. ඒ වෙනස්කමට හේතුව කවුද? ඉන්න අයම තමයි. ඉන්න අයගේ ඇටිටියුඩ් කියනට අපි අපේ පැත්තෙන් කන්ට්‍රිබියුෂන් එකක් තියෙනවා. ඉන්ස්ටිටියුට් පැත්තෙන්, යුනිවර්සිටි එක පැත්තෙන්. ඒ ඔක්කොම තියෙනවා. මොකද ඉන්ස්ටිටියුට් එකේ දින සමාලාට ඇටිටියුඩ් හදන්නේ. ඉන්ස්ටිටියුට් එකකින් කිව්වොත් එහෙම ඔන්න ඔය ගානක් නැහැ ඔන්න ඔය මොනායි බොරු ටිකක් කරලා ඉරපල්ලා. බොරු ජොබ් එකක් හොයාගෙන ඉන්න උඹලට මොන software development උඹලට මොන IT field උඹලා ඔන්නේ ලංකාවට වෙලා හිටපල්ලා. නම් තව ඩිග්‍රී එකට යන එක කයින්ට් හැමදාම ඔලුවට දානවා නම් ඕගොල්ලෝ තමයි හොඳම කට්ටිය. ඕගොල්ලෝ තමයි මේ ඉස්සරහට IT field එකේ තරු ටික. ඒගොල්ලෝ එහෙම හැසිරෙන්න පටන් ගන්නවා. ඕගොල්ලෝ මේක ඇතුළේ මෙලා ඉන්න එපා. ඕගොල්ලෝ දැන් මේ ඉඳලා කල්පනා කරන්න මයිග්‍රේට් වෙන විදියට. එහෙ ගිහිල්ලා ජොබ් සෙට් කරගන්න දැන් මේ ඉඳලා. බලන්න මේ මොන ජොබ්ස් වලටද මොන ජොබ්ස් තියෙන්නේ කියලා. ඒ ඇටිටියුඩ් එක හැදෙන්නේ නැත්නම් නැත්තම් රැකියා විරුද්ධ උපාධිධාරී කාලකන්ණි හදා ගන්නත් පුළුවන් අපිට. Right. So any right. I hope no questions are there. So I'll share this table also. Close කරන්න. කොයි සේව් වුණාද දන්නේ නැහැ. Right. So you know now how to model one-to-one relationship, how to model one-to-many relationship, and how to model many-to-many relationships. Okay. If it is a binary, you know how to do that. If it is unary, still you know how to do that. Okay. Right. So next thing is ternary relationship. Ternary relationship. So ternary relationship means it's a relationship between three entities, three tables. Okay. So one of you has mentioned that you can ask questions if I explain it in singular. So I don't want to do that because this is semester 2. So I also conduct English grammar with you. You learn English grade 1, grade 2, grade 3, grade 4, grade 5, grade 6, grade 7, grade 8, grade 9, grade 10. Right? උදේ ඉස්කෝලේ ඉංග්‍රීසි ඉගෙන ගන්නවා හැන්දෑවට ටියුෂන් ගිහිල්ලා ඉගෙන ගන්නවා සමහර O level කරලා ඉංග්‍රීසි පන්ති යනවා A level කරලා ඉංග්‍රීසි පන්ති යනවා මෙච්චරත් ඉංග්‍රීසි පන්ති ගිහිල්ලා තාමත් ඉංග්‍රීසි බැරි නම් හරි පාට කියන්න බෑනේ අවුරුදු 10 තිස්සේ ඉංග්‍රීසි ඉගෙන ගන්නවා කියලා අර කොරියන් යන එලකිරි කොල්ලෝ කෙල්ලෝ ටික මාස් 3 කොරියන් ඉගෙන ගිහිල්ලා එහෙ ගිහිල්ලා හොඳට කාලා බීලා සුවමාකට් වලට ගිහිල්ලා බඩු අරගෙන ජීවත් වෙනව නේද so therefore this is enough right? This is enough so you must communicate in English. Semester 1 exam එක ලිව්වේ ඉංග්‍රීසියෙන් නෙමෙයි එතකොට. ඒක පාස් වුණේ කොහොමද? So therefore you can ask questions in Sinhala but this course is conducted in English medium. Whether it's SLIT or NSBM or University of Morocco or UCSC so they all conduct IT courses in English. ඒක වෙල්ලාස විශ්වවිද්‍යාලෙත් ඉංග්‍රීසි වලින් තමයි උගන්වන්නේ. So you must get into that standard. Okay, you must get into that standard. Okay. Otherwise, it's not going to work. Interview single in the end. IT interview single in the end. IT interview then English medium. HTML and SQL and single in English or in. So get into that mode. Get into that aggressive mode, right? Otherwise, it's never work. Right? But single prashna and pulwa. Single prashna and pulwa. It doesn't matter. Okay. So we have taken that firm decision. Because you have so many resources available, right? මම උදාහරණයක් කියන්න. මම අද එක ස්ටුඩන්ට් කෙනෙක් FIT ස්ටුඩන්ට් කෙනෙක් chat එක තාම ඇති. පේනවා. no understand තේරෙන්නේ නැහැ කියලා තියෙනවා. මම ඉංග්‍රීසියෙන් දුන්න එක. මම කරේ මොකද්ද? ඉංග්‍රීසියෙන් දාපු එක. දැන් මේක තේරුම් ගන්න බැරි නම් අඩු ගන්න මේ ළමයට පුළුවන්කමක් තියෙනවනේ මේක ගිහලා Google Translate එකට දාලා මට තේරෙන්නේ නැහැ කියන්න දෙයක් නැහැ. මෙච්චර තාක්ෂණය තියෙනවා. නේද? English to Sinhala. මම යවපු ටෙක්ස්ට් එක මම මේකට ගැව්වා. වෙන මොනා කරන්නද නැතුව ඉතින්. මම දැම්මේ Google Classroom invitation is already sent to your Gmail. You have not accept the invitation. මේක තේරෙන්නේ නැහැ. මං ඉතින් මොකද කරේ? මේකට දාලා ඉවරලා මේක ස්ක්‍රීන්ෂොට් එකක් ඒවා Google පන්ති කාමරේ ආරාධනාව දැන්ටමත් ඔබගේ Gmail එකට යවා ඇත. ඔබ ආරාධනාව පිළිගන්නේ නැත. එතකොට එහෙම කිව්වම තේරෙනවද? හරි. මං කරේ මේක ස්ක්‍රීන්ෂොට් එකක් ගාලා ආයෙවුවා. ඇයි මේ තාක්ෂණයේ තියෙනවා කියලා දැනගන්නත් එපා ඒගොල්ලෝ නේද? මේ තාක්ෂණයේ තියෙනවා කියලා දැනගන්න ඕන ඕගොල්ලෝ. හරි මේ මම යවලා ඊට පස්සේ තේරුණා කියලා තියෙනවා. So you must start using English, okay? Because you are doing IT. You are doing IT. නැත්තම් මැරෙනකම්ම මේ වැඩේ වෙන්නේ නැහැ. ඔයගොල්ලෝ හොඳට මේක කරන්නේ. ඔයගොල්ලොත් එක තරහකට නෙමෙයි. මටත් ලේසි සිංහලෙන් කරන්න මේක. දාන්න සිංහලෙන් හරි මොන මගුලෙන් හරි. But that doesn't work. අන්තිමට ඉන්ටර්විව් එකට ගිහලා සිංහලෙන් දාන්න සිංහලෙන් ඉන්ටර්විව් කරන්නේ නැහනේ. හරි. ජොබ් එකකට ගියාම. So therefore get into this mood. Okay, very aggressive mood. ඔයාලට තරම් කරන්න ඉන්නවා. ස්ට්‍රිට් එකේ අය ඉන්නවා. NSBM එකෙන් ඉන්නවා. හරි. දැන් කොතලාව ඩිෆෙන්ස් එකෙන් එනවා. IIT එකෙන් එනවා එන සෙට් එකක්. මොරටුවෙන් එනවා IT මොරටුවේ IT ෆැකල්ටි එක තියෙන ඒවයි බලන්න කියලා සිංහලෙන් වචනයක් කරනවාද කියලා. එක වචනයක් කතා කරනවාද කියලා lecturers. Because that is the standard we need to maintain. Okay. ඔය semester 1 වල මම සිංහලෙන් කතා කරා සෑහෙන. ඒව ඩිග්‍රීස් ඉගෙනුවත් එක්ක. ඒතකොට ඒකෙත් ඉංග්‍රීසි ඉගෙන ගන්න නැහැ ඊට පස්සේ. ඒකෙත් ඉංග්‍රීසි ඉගෙන ගන්න නැහැ ඊට පස්සේ. කවදාද ඉංග්‍රීසි ඉගෙන ගන්නේ? වරද්ද හරි අපි මේක කරමු. නැත්නම් තොইলයක් කරමු. කවුරු හරි බය කරලා දිනනවා නම්. යාතිකාවක් කළා. Right. So now let's finally look at how to model ternary relationship. Ternary relationship. So that is a relationship between three entities. So when you do your final project, sometimes you encounter ternary relationship. දැන් සමහර final year student ලා final year project එක කරගෙන යද්දි ඒගොල්ලෝම model කරලා තියෙනවා ternary relationship. ternary එක නැතුව ඒගොල්ලන්ට එතන ඉස්සරහට යන්න බෑ. ternary එක නැතුව මේක ගොඩ දාන්න බැරිද? නෑ ගොඩ දාන්න බෑ. එක්කව project එක මාරු කරන්න. මේක කරනවා නම් මේක ternary එකකින් කරන්න නැත නිකන් ඉන්න. නැතව වෙන project එකක් කරගන්න මොකක් හරි හැමදාම කරන library management system හරි මොනවා. මේවට වෙන option නෑ හරි. එතන surgery එකක් කරන්න ඕන නම් surgery කරන්න ඕන. ඒකට මේ බොරුවට මේ නේද? බොරු කතන්දර කියලා හරියන්නේ නැහැ. surgery කරලා ඉස්සරහට යන්න. So that is how engineers do. Doctors නේද? doctorට එතන surgery කරන්න ඕන නැහැ. surgery කරන කකුල කපන්න ඕන නම් කකුල කපනවා. So therefore even when you do your final year project, there might be a possibility that you have a ternary relationship. So then you must know how to do it. There's no other option. Okay. Right. So let's take some examples and let's design it. So what is the example we took? මතකද අපි ගත්ත example එක? Product, brand, warehouse. From this product, from this brand, in this warehouse, we have this number of items. Right? Today we'll take a different example. Okay. It was an old example like say there's a selling happening. Say buying and selling. So we coordinate. Or not we coordinate, the coordinators are also there. අපි හිතමු අපි website එකක් හදනවා. හරි. ඕකේ ඉන්න buyers ලා. sellers. and කවුද අර කියන්නේ කොන්ත මම මේවා කරන කට්ටියට කවුද කියන්නේ මට මතකයි නම. කාටද ඒගොල්ලන්ට කියන්නේ buyers උයි sellers කාටද නම මතකද? නෑ. අර මේ කපුවා වගේ පැදිහත් වෙන කෙනාට කියන්නේ නම මොකද්ද? සිංහල නම කොහොමද?
urgent,
හා? Can you repeat? මට ඇහුන්නේ නැහැ වගේ පෙර.
urgent,
Agent. ආ ඔව්. හරි agent. So
urgent.
sorry?
Oh,
I didn't hear it. Okay. Whoever. Who does the coordination, right? So who does the coordination? අපි කියන්නේ ඒගොල්ලන්ට කවුරු කියලාද මේ ඉන්නේ මේ කඩ මේ ඔෆිස් දාගෙන ඉන්නේ නේද? මට මතක නම් මතක නෑ හරි. So he is the one who coordinate this sales, right? He is the one who coordinate or meet the buyer and seller and he get a commission. He get a commission. So then when there's a selling, there are three parties: buyer, seller, that coordinator. Let's call it coordinator. Right? So all three parties involved, because if this total revenue this particular agreement is say 10 million, so this guy is going to get some percentage of the commission. Okay, percentage of the commission. Yeah, commissioner හරි අන්න හරි commissioner කියලා නේද ඒකට කියන්නේ මම දන්නේ කොමිස් ගහනවා ගණේ වන්න මට මතක නැහැ හරි right අපි කියමු coordinator කියලා පොඩ්ඩක් ලස්සන නමක් දෙමු මට පොඩි වැදගත්කමකුත් දෙමුකෝ අපි කියමු coordinator කියලා brokers නේද අර ගහන්නේ නේද no brokers කියලා brokers ලා කියලා කියන්නේ broker කියලා දාමු broker right buyer seller and broker okay so the broker is the one who coordinate it and we have potential buyers potential sellers and when there's a transaction it is between the buyer seller and broker okay so it's a ternary relationship it's a ternary relationship so this transaction is involving one buyer one seller and one broker okay one buyer one seller and one broker now it's a ternary relationship okay ternary relationship so let's do it in the same database because our database eකට යන්න වෙනවා let me open the database again access අපි ඒක unary ගාවට ඒක ternary එකකුත් හදනවා හරි නැත්නම් අපි database පොඩ්ඩක් හදන්න වෙනවා right so let's create a table called buyer ඕනනම් buyer seller දෙන්නම එකට දාන්න පුළුවන් දෙන්නම users ලා කියලා මුත් අපි so we say we register buyers separately we register sellers separately right අපේ website එකට හරි කොහෙද so therefore I will call this buyer there we will have buyer ID and maybe buyer name B name then එච්චරක් ඇති කිරිතමු so similarly I want to have a seller table okay capital name නේද ඔක්කොම එක විදිහට කරමු Oscar Linder buyer so let's create a table called seller again let's call it seller name seller ID seller ID auto number primary key and S name මට name කියන keyword එකක් අද පාවිච්චි කරන්න දෙන්නේ නැහැ ඒකයි S එකම දාන්නේ right so now I have the buyer and seller now let's say අපි දැන් නමට ආයෙ නම් මතක නැහැ broker so brokers are separately registered broker broker ID let's call it B name broker name right Now there can be a transaction. So the broker has basically coordinated the sales between the buyer and seller. So when that transaction happens, all three parties are involved. So it's a ternary relationship because the transaction involves three parties: buyer, seller, broker. It's pretty much the same when it comes to share market. Okay, share market also, when you buy shares. Okay, so when you buy shares, you are a buyer. Of course, there's no seller. Seller is based, yeah, seller is also there, right? You're buying, yeah, so same thing. So you are buying from someone else. Right? So you are buying shares from someone else. But your transaction is coordinated by a broker. Actually, in that case, there can be two brokers. One broker is coordinating the seller, the other broker is coordinating the buyer. So these are the real world scenarios. Okay. But let's forget about that. Quaternary. Right? Brokers are දෙන්නෙක් ඉන්නවා. seller ගේ broker, buyer ගේ broker. Okay. ඔයගොල්ලෝ share market එකෙන් shares ගන්න අපි දීලා යන්න බෑනේ broker කෙනෙක් කරානේ ගන්නේ නේද? අපිටත් ගන්න පුළුවන් direct බෝගෙට broker කෙනෙක් කරා ගන්න. sell කරන්නේ broker කෙනෙක් කරා. Okay. broker තමයි ඒ වෙලාවට sell කරන්නේ කාට? price බලලා. But this is, forget about that. This is අර ඉදමක් විකුණනවා වගේ කතන්දර. දෙන්නට brokers දෙන්නේ නැහැ. එහෙමනොත් එම් quaternary වෙනවනේ. Now this is a quaternary, ternary relationship. So therefore, if it is a ternary relationship, again you need connecting table. Okay, connecting table. So I'll create another table and I will call it something like transaction. Okay, transaction. නැතර නම් තුන දාන්න ඕන. buyer underscore seller underscore broker කියලා. So rather I will call it transaction. Transaction. So now what are the fields we need for the transaction table? Let's make it capital. You have the seller ID. This is a connecting table. Buyer ID and the broker ID. And you can't make it auto number, let's make it number because those are foreign keys. And this combination, all three is the primary key. ඔය තුනේ combination එක තමයි primary key. Okay. You can see it's a composite primary key involving three fields. All three are three foreign keys. And maybe date of transaction ඔන්න ඒවා මෙතනට එනවා. Right. Date of transaction. Maybe transaction amount. Sorry. Transaction amount. So those things come here. Say currency. Now I have the 4 tables, 3 tables and the connecting table. Right. So now let's go to the database tools, relationships, view tables. Oh, view table එකටත් මොකද වෙන්නේ අපේ? කොහොමද tables ටික? Table වැඩිද දෙයාගේ? Yeah, at table වලට යන්න. මෙහිලා යන්න. Right. So now I will add seller. I will add buyer. Okay. I will add broker. Okay, broker. And then I need the connecting table. that is transaction. Right? So this, we are going to create the ternary relationship. So this seller ID, I will map it to the seller ID. And it will be one-to-many. Enforced referential integration. And this buyer ID, I will map it to the buyer ID. So this broker ID, I will map it to the broker ID. And this is how you create ternary relationship. Okay. Now now I can close it. I can add some buyer sellers now. I'll say S1, S2, S3. So I have 3 sellers. Maybe I have 4 buyers. B1, B2, B3, B4. Let's say I have 2 brokers. Broker 1, broker 2. Now there are some transactions happening. Say buyer seller 1, buyer 2. This transaction is coordinated by broker 1. And that happened in that particular day. And the transaction amount is, say, 1 million. So there's another transaction between seller 1 and buyer 1. It is coordinated by broker 2. And it happened in this particular day. And amount is 150 million. Okay. And so then we data I can keep the data. Buyer's data. This particular transaction is between this buyer, this seller, and this broker. This transaction is between this buyer, this seller, and this broker, and this is the date, this is the amount. Okay. So that is how you do ternary relationship. So you introduce a connecting table, right? You introduce a connecting table. Okay. Right. So let's continue. I will share you the table at the end because sometimes I may have to add 1 or 2 more tables to this one. Right. Any questions about unary, binary, ternary, one-to-one, one-to-many, many-to-many? Ternary, don't consider about one-to-one, one-to-many, many-to-many separately. Just consider it as a unary, ternary relationship. But definitely, binary one-to-one, binary one-to-many, binary many-to-many, unary one-to-one, unary one-to-many, unary many-to-many. And then you have the ternary. Any questions? If you have any questions, you can ask. Because from this point onwards, things must be either crystal clear or you have 150 questions with you that you need to clarify today itself. එක්ක වැඩේ එලකිරි වගේ තේරෙලා නැත්නම් දැන් ඔගේ ප්‍රශ්න 150ක් විතර තියෙනවා අහන්න. ඔක්කොම අහන්න. No question? That means perfectly understood, okay? Finally ගිහිල්ලා හිගන්න වගේ යන්න බෑ මේ එක එකනා පස්සේ මේ ප්‍රොජෙක්ට් ක්ලාස් කර නැත්නම් ප්‍රොජෙක්ට් පරණ ප්‍රොජෙක්ට් ඔය සල්ලි වලට දෙන හැටි ඔය මේ සයිට් එකකට ගිහලා බලන්න සයිට් නෙමෙයි මොනවාද ගෲප් එකකට ගිහලා පෝස්ට් එකක් දාන්න මේ ප්‍රොජෙක්ට් එකට හෙල්ප් එකක් නැද්ද කියලා ටක් ගාලා ඉන්බොක්ස් එන්න කියනවා ඊට පස්සේ කයි ගාන මෙච්චරයි කියලා ප්‍රොජෙක්ට් තියෙනවා අපි ගාව සල්ලි වලට කියලා ප්‍රොජෙක්ට් අනුග ගිහලා කරගන්න මොකටද අවුරුදු 3ක් තිස්සේ ඉගෙන ගත්තේ ජොබ් එකට එකයි යන්න කෙනෙක් එක්කයි යන්නේ. මට ජොබ් එකක් හම්බුණා මම වෙනුවෙන් ජොබ් එකට එන්න කියලා. මම ඔයාලට එකකින් ගන්න එහෙම දෙන්නේ නැහැ නේ. ඒක ප්‍රායෝගිකව වෙන්නේ නැහැ නේ. It doesn't work. ඔයගොල්ලෝ දැකලා තියෙනවද වෙන තැන්වල මේ මෙඩිකල් කොලෙජ් වල ඉන්න මෙඩිකල් ස්ටුඩන්ට්ලා දානවා මේ මගේ ප්‍රොජෙක්ට් එක කරලා දෙන්න. වෙන ඉන්ජිනියරින් ස්ටුඩන්ට්ලා දානවා මගේ ප්‍රොජෙක්ට් එක කරලා දෙන්න කියලා. ස්ලිට් එකේ NSBM එකේ මොරටුව කැම්පස් එකේ කොළඹ UCSC එකේ ඉන්ටර්නල් ස්ටුඩන්ට්ලා අර පෝස්ට් දැක්කම ඇත්තටම අපිට සසර කලකිරෙනවා. සසර කලකිරෙනවා මේ මොන හරක්ද? මොන බොරුවක්ද මුන් කරන්නේ කියලා. ඊට පස්සේ කියන්න එපා මේකට තැනක් නැද්ද? ඔය ඒක බැලුවොත් එහෙම තැනක් නෙමෙයි. පොල් පිටෙන් අල්ලන් ගහයි. ඒක ඉන්නේ උන්ටත් පෞරුෂයක් නැහැ පාංකඩයට. නැත්තම් ඌ අල්ලලා එල්ලන්න ඕන. යකෝ අපේ ඩිග්‍රිය මේ කන්නේ කියලා. ඔහේ ඉන්න පාංකඩය. කවුරුත් ඒකට විරුද්ධ වෙන්නෙත් නැහැ. දැන් අපි ඉන්නවනේ NSBM එකේ ස්ට්‍රීට් එකේ ගෲප්ස් වලත් ඉන්නවා. කවදාවත් මම දැකලා නැහැ එහෙම මේ පෝස්ට් දාන්න. සල්ලි වලට ප්‍රොජෙක්ට් ඉල්ලලා. මොකද ඒගොල්ලෝ ඉගෙන ගන්නවා. ඔය ඉන්ටර්නල් ස්ටුඩන්ට්ලාගේ ඒවා එහෙම මේගොල්ලෝ ඉගෙන ගන්නවා. ඒගොල්ලෝ ඉගෙන ගන්න තමයි මේ කෝස් එක කරන්නේ. මං කියන්නේ ඔක්කොම කියලා right? එහෙම බොරු කරන්න දැම්ම ඉඳලා හිතේ තියාගෙන ඉන්න සෙට් එකක් ඉන්නවා. තනි බොරුවෙන් ජීවත් වෙන්න. අන්තිමට අපරාධ ගෙවල් වෙන දෙමව්පියොත් පව්. මොකද ඒ මිනිස්සුන්ගේ සල්ලි සමානලා. Right. So now we have covered all these things. Right. We have covered all these things. Now we move on to some constraints. So constraints are restrictions that we enforce to maintain integrity. Integrity means not broken. කැඩිලා නැහැ කියන එක. Right? කැඩිලා නැහැ කියන. So the relationships are properly maintained. So there are three main constraints: entity integrity constraint, referential integrity constraint, and other field level constraints. Some of those are domain constraints, domain integrity constraints. So what is mean by entity integrity constraint? That design caliber karna. Right. So entity integrity constraint means your primary key field must be unique and it cannot have null value. Anyway, that is by definition also. Your primary key field must be unique and it can't be null. So that is called entity integrity constraint. So you may have null values for your contact number and blah blah blah, but never ever your primary key. You can't have a student with null student ID. You can't have a payment with null payment ID. And of course, it can't be duplicated. Then of course, the whole purpose of primary key is right destroyed. Right. Any questions about that? Entity integrity constraint? So cardinality of the transaction, yes. Once you design it, all are one-to-many. Yes, I forgot to mention about that. Sorry for that. Okay. So if you look at this, let me revisit. I think I didn't explain it enough. Right. So you can see that it's basically once the connecting table is added, those are all three one-to-many relationships. This is one-to-many, this is one-to-many, this is one-to-many. So if you don't have this, again, you can think of it as sort of a many-to-many relationship. So there can be one seller with many buyers, one buyer with many sellers, one seller with many brokers. Yeah, overall, it is many-to-many relationship, right? Many-to-many relationship. And once it's model, what you get is three one-to-many relationship. Okay, three one-to-many relationship. Sorry for that. I forget to mention that. Okay. Right. Yeah. So your explanation is correct. So that is why we added the mapping table. Yeah. It's ultimately sort of a many-to-many relationship. Always. Right. So now you know what is entity integrity constraint. Entity integrity constraint says your primary key value must be unique and cannot be null. Okay. So the second integrity constraint is referential integrity constraint. So referential integrity constraint says the foreign key value must be a valid value from the related table, or it must be null. So remember, whenever we create relationships, I always ask you to check enforce referential integrator. You can see each and every place, whenever I create a relationship, need to select this. I check that. Right? So that is why when I add a wrong value, for example, right? For example, if I add to the transaction table a seller ID or buyer ID or broker ID, which doesn't exist, like something like, so remember, you know that there's a seller ID called 1, there's a buyer ID called 1, and of course I can have 1 again because this combination is not yet there. Okay, 1 1 1, say 100,000. Now I can save this. But if I add a wrong broker ID, there's no broker called 3, right? No broker called 3. Now if I save it, right, you can see you cannot add or change a record because a related record is required. So related record means you first need broker 3. Without broker 3, you can't have broker 3. So that is why do you get that error message? Because we have enforced referential integrity. But if I change it to something like 2, now what will happen? Now can I save this? Can I save this? Yes or no, and reason. If it is yes, why? If it is no, why? Can I save this? So far I have 1 1 2. But pain natham podina 1 1 2. That is seller ID, buyer ID, and the broker ID. Then second record 1 2 1. Now I try to save again 1 1 2. Now can I save this record? Yes. Reason? No. Again you must view the reason. Yes, reason, no reason. So I need the reason. Just yes or no is not going to work. I need the reason. Just using 1 or 2 words, explain why. Why not? If you say yes, you explain yes. Because of this, it is okay. Now you can see that already we have a 1 1 2 combination. Remember, primary key must be unique. That is what is meant by entity integrity constraint. So now this violate entity integrity constraint. Earlier referential integrity constraint is violated. Now if I try to save this, entity integrity constraint is violated because this combination is already there. So your primary key value must be unique. So therefore I'm going to get an error again. Right? So let's save it and see. Right. ඔන්න මොකක්ද හැලක් කියනවා. Right. Blah 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 ඔය කෑ ගන්නකොටද මේ entity integrity constraint එක පටලවගෙන. So but if I change it to something like 1 1 2, right, 1 1 2, and now it is okay because there's no 1 1 2. Now I know I 1 1 2 save kara. Maybe this one. 1 1 2 is also there. Sorry. So what about 1 2 2? Yes, 1 2 2 should be okay because there's no 1 2 2. Now this it should be okay. Now I can save it. You can see, I can save it. So it doesn't allow you to violate entity integrity constraint. It doesn't allow you to violate referential integrity constraint. So those two are enforced. By default, entity integrity constraint is enforced. If you mark enforced referential integrity in when you create the relationship, that is also enforced. Okay. Right. So that is what referential integrity constraint is. So others are basically domain interconstraints. So domain constraints are not coming from relational theory. Domain constraints are coming from the business rules. So the two constraints that coming from relational theory is entity integrity constraint and referential integrity constraint. Domain constraint means any other constraint which is related to some business policies, business rules, or domain rules. For example, if it is marks, maybe it must be between 1 to 100. Okay. If it is gender, maybe male or female, something like that. So if it is a grading, only valid values are maybe A, B, C, F. So if someone enter something like X, it should give me an error. So those, if you enforce that kind of things, we call them domain constraints. Like maybe maximum width, value ranges, possible values, okay, and so on. Those are the three type of constraints. And of course, there can be some other technical constraints like unique constraint. Maybe we can set it to non-primary key field. Say email address must be unique. No two users can have the same email address. Maybe email address is not your primary key. So then it's again a constraint. Or null constraint, null values are not allowed. Not for primary key, maybe for a different field. But it's not a primary key. Still, you can enforce null constraint, not null field. Okay. Right. Any questions? Any questions? Right. So now we'll move on to normalization. So before doing the normalization part, right? So there's a small subtopic or subpart we need to finish. Then only we can start the normalization. Anyway, this is also in your normalization syllabus. Okay. So there is functional dependencies. So we'll first do the functional dependencies. Then we will move on to the normalization. Okay, so I just waited for the start this normalization until we finish the relations and functions. Now we have done the relations and functions in math subject. So now we are in a position to start this topic. Okay, right. So these topics are interrelated. So sometimes I just delay some topics so that we finish some related topic in some other topic, and then we don't have to duplicate the effort. Okay, right. Functional dependencies. Okay. So now remember you learn about relation, the logic, Boolean logic in math subject. Okay. So this is something related to that, but not 100% the same thing. Or I will say something like this. So this is, so Boolean logic is related to sets. Functional dependencies are also related to sets. Okay. So this is slightly different concept, but you can understand Boolean logic using sets or with the help of sets. Similarly, you can understand functional dependencies also with the help of sets, but you can't 100% rely on sets also. It's a slightly different topic as well. And understanding functional dependency is super important when it comes to relational databases or designing relational databases. Okay. So therefore, let's try to understand, or try to understand. At the end, you must be 100%, right, able to understand what is functional dependencies, right? So functional dependency describes relationship between attributes. Maybe this attribute is functionally related to another attribute. Or we say A1 functionally determines A2. This is the terminology we use, and this is the symbol we use. This is not the logic symbol if else. Right? So this is not A implies B. So of course, in logic, this means A implies B, and we have truth table also. But in this topic or in database subject, this means A functionally determines B. Okay. A functionally determines B. So what is mean by A functionally determines B? That means if I know A, I know unique value of B. Again, this will take a little bit of time to understand. If you want to speed up, you ask questions. As simple as that, right? So you can understand it in hard way, that is by yourself, Yes, that is fine. As long as you have that commitment, courage, do it. You have that time. But if you want to speed up, ask questions. Right? If you want to speed up. But sometimes you like to do it in a small, your own. So that is also fine. So everyone is different, right? Sometimes you want to know, I will do it by myself. I will take my time. Or someone will say, no, I don't have a lot of time. I just want to ask all these questions, clarify here itself and do it. Right. So what does it mean? A functionally determines B. So that means when you know A, you know a B, as long as you have the information. Okay. So A function determines B does not always mean B function determines A. Maybe A function determines B, but maybe B does not function determines A. Okay. So that possibility is there. So that means when you know the value of A attribute, you can give the value of B attribute without any issue, as long as you have the access to the data. But there can be situation when we know the value of B, you may not in a position to give the value of A. Okay. So then we say B does not functionally determine A. Okay. So therefore function determines means basically for one A value, there is only one B value. There is no possibility of more than one B value. If there's a, if you know, when you know A value, if there's a possibility of multiple B values, then we say A does not functionally determine B. But if for one A value, if there's only one B value, that means A functionally determines B. In other words, it is something like if it is 1 to 1, okay, or many to 1, A functionally determines B. 1 to 1, or even if we don't care, many to 1. Say there's something called A5. A5 also map to B1, but it's okay. Because once you know A5, you know that it is B1. So A function determines B. But here, when you have A1, you don't know exactly whether it's B1 or B2. So that means it's one to many. When it is one to many or many to many, right? So then the left side value does not determine right side value. Is it clear, or you need more explanation? No, this is completely different concept, okay? So this is completely different thing I'm talking now. Okay, it's completely different concept. So let's take a practical example. Right? Say I have a table, say student or something, which has NIC, first name, last name. So if I have access to this data, okay, assume that I have the access to the table. If someone tell me a particular NIC number, you know that I can definitely say what is that person's first name, what is that person's last name, as long as I have this data. Because NIC is unique. NIC is a primary. So let's assume NIC is my primary key. So then definitely there can't be two records with the same NIC number. And if I know the NIC number like this, I know that this person is Kevin David. So therefore I can say NIC functionally determines first name. NIC functionally determines last name. Okay. Because one NIC is mapped to only one first name. One NIC is mapped to only one last name. So therefore NIC functionally determines first name. NIC function determine last name. So this is little bit serious stuff. It's not difficult, but initially sometimes you may feel you understand it, but maybe you haven't understood it or full enough. Maybe you have misunderstood it. Yes, so this is something related to primary key as well. So that is a good guess. So most of the time this left run is most of the time left one is going to be a primary key, but not all the time, because remember there's a possibility of alternative keys, alternate keys. Okay. But anyway, that's a very good guess. Okay. So before I tell you, it's good that you guess it. Yeah, so this left side is more almost all the time. If it is if it functionally determined, your left side is going to be either primary key or sorry, alternate key. Because then only you can specifically say this is the name, this is your email address. Okay. Now you can see that if I know last name of a person, I can't say exactly what is NIC. For example, so this person is Ruvini Silva. This person is Ruvini Fernando. So if someone asks me, can you tell me the NIC of Ruvini? No, I don't know. Maybe this one, maybe this one. Okay. So therefore, you can see last name does not function determine NIC. First name does not function determine NIC. Okay. And not only that, even first name does not function determine last name does not function determine first name. For example, when it is Ruvini, I don't know this last name is Silva or Fernando, because that is not enough. But if I know the NIC number, I know whether the last name is Silva or Fernando or whoever. Okay. So that is what is mean by functionally determines. A functionally determines B. So A functionally determines B if A is a candidate key or A is a key. Otherwise, A does not function determine B. Okay. Candidate key of that particular entity. Then it function determines all the other attributes. Okay. And this concept can be extended to, now this, we initially build that concept for what? Attributes. Attributes. Now, computer engineers, computer scientists have built this concept into abstract level. And you can even think of that entity functionally determines another entity. But ultimately, it is your attributes. But you can say something like employee functionally determine department. That means if you know an employee ID, you know his or her department ID. Basically, the reason is your employee ID is mapped to a department ID. But it doesn't mean that just because you know the department, you know the employee, because there can be multiple employees. So what we need is, of course, we can say all the employees in that department, but you can't uniquely say department employee ID because there are multiple employees. So functional determined means this one must be able to uniquely identify one value in the second one. Like when you know the NIC, you know exactly what is the first name. Okay. Right. So when it comes to functional dependencies, there's something called Armstrong's axioms. And again, this is super, super important for your logical thinking, critical thinking. මේ functional dependency කියන එක පේන්නේ නැති වුණාම තමයි අපිට සමාජයේ වෙන දේවල් තේරෙන්නේ නැති. දැන් රට බංකොලොත් වුණාම ඕක මැප් කරනවා. දැන් ලංකාවේ තියෙන ප්‍රසිද්ධම කතන්දරේ මොකද්ද? bankrupt නේද? හිඟන රටක් තියෙනවනේ දැන්. bankrupt country. ඕකට මැප් කරලා තියෙන ප්‍රසිද්ධ කතන්දරේ මොකද්ද? රාජපක්ෂ කියලා මැප් කරලා දේශපාලනය හැදුවා. රාජපක්ෂ රට බංකොලොත්. ඕක නේද ඔක්කොම මෝඩ 70 කියවන කතන්දරේ. ඕක දැන් මෝඩ 70 කියවන කතන්දරේ. ඇහුවොත් කියන්නේ පාරක තොට ගියා ත්‍රිවිල් එකකට නැගගත් රාජපක්ෂ රට බංකොලොත් කරා. රාජපක්ෂ රට බංකොලොත් කරා. ඒ කියන්නේ මේක හන්ද මේකුණා. තනිකර ෆන්ක්ෂනල් මේ ඩිපෙන්ඩන්ස් තමයි කතා කරන්නේ. නමුත් ඇත්ත කතන්දරේ ඒකද? ඇත්ත කතන්දරයක නෙමෙයි. මොකෝ රාජපක්ෂ රට ආක්‍රමණය කරේ නෑනේ බලහත්කාරයෙන් මේ මිනිස්සු ඡන්දෙන්න දුන්නේ. 3න් 2කට ලං වෙන්නම ඡන්ද දුන්නා. 3න් 2කටම ලං වෙන ඡන්ද දීලා ඉවරලා ඊට පස්සේ කියනවා රාජපක්ෂට රට බංකොලොත් කරා. ඊට පස්සේ කියනවා 255ම මරන්න ඕන. 255ටම ඡන්ද දීලා දෙන මිනිස්සු ඉන්නේ නැත්නම් රටේ පුරවාසී ඔක්කොම මරන්න ඕනද? මොකද ඊළඟ පාරත් ඒගොල්ලන්ට ඡන්ද දී. සෝ ඔය ඩිපෙන්ඩන්සි පේන්නේ නැහැ සමහරුන්ට. මොකද ඇත්ත කතන්දරේ කියලා. ඇත්තටම මේ මොකද්ද ඩිපෙන්ඩන්සි එක කියලා? Right. So therefore, it's very important that you understand these how these functional dependencies work. Okay. So these Armstrong axioms really help us understand these functional dependencies. Okay. At a theoretical level. Right. So what are the Armstrong axioms? Axioms කියන්නේ ප්‍රත්‍යක්ෂ. ප්‍රත්‍යක්ෂ කියන්නේ ඔය කියන්න විතරයි මට තියෙන්නේ. මම මේක ඔප්පු කරන්න යන්න බෑ. ඔප්පු කරන්න යන්නේ නැහැ. ඔප්පු කරන්න යන්න බෑනේ ප්‍රත්‍යක්ෂ. ප්‍රත්‍යක්ෂ කියන්නේ ප්‍රත්‍යක්ෂ. ඒක ඔයාලට ඇඟට තේරෙන්න ඕන. ඔයා කල්පනා කරාට පස්සේ. Axioms. Okay. or postulates. මතකද පළවෙනි axiom එක? මේ කෝණ දෙක සමානයි කියලා. ඔක කවුරුහරි ටීචර් කෙනෙක් ඔප්පු කරේ නැහනේ. ඇස් තියෙනවා නම් බලපල්ලකෝ මේ දෙක සමානයි නේද කියලා. Axiom එක ප්‍රත්‍යක්ෂය. Right. So first one is reflexivity. So reflexivity axiom says A functionally determines A. So if you know the NIC number, you know the NIC number. So you have no doubt. If you know someone's first name, you know that person's first name. ඒක ප්‍රත්‍යක්ෂයක් නේද? ඒක ප්‍රත්‍යක්ෂයක් නෙමෙයි නම් කල්පනා කරලා බලන්න. ඒතර අනිත් අයගෙන් අහන්න ළඟින් ඉන්න කෙනෙක් ඔයාලට ඒක ප්‍රත්‍යක්ෂයක්ද? බොහෝ විට බෞද්ධරිකය ප්‍රත්‍යක්ෂයක් කියලා. ඒකනේ ප්‍රත්‍යක්ෂ කියන්නේ. බෞද්ධරි මිනිස්සු නම්. Right. A functionally determines A. Okay. So that is obviously yes. හැබැයි එහෙම කිව්ව පළියට පිළිගන්න එපා. මම කිව්වම obviously yes කම ඔව් obviously yes කියලා. You think about it. ප්‍රත්‍යක්ෂ කියනවා හිතන්න එපා කියන්නේ නැහැ. අපි ප්‍රත්‍යක්ෂ හිතලා ප්‍රත්‍යක්ෂ කරගන්න. සැක තියෙනවනේ සැක අරගන්න. කතා බහ කරලා. අනිත් පැත්ත එක්ක. Right. So second one is if A functionally determines B, B functionally determines C, then A functionally determines C. This is the most important one. Right. If A functionally determines B, that means if I know A, if you know exactly what is B, there's no ambiguity, only one B value. Then if B function determines C, that means if you know B value, if you know exactly what is the C value, there's no ambiguity, there's no two values. So then you can say A functionally determines C. So that is called transitivity rule or axiom. A functionally determines B and B functionally determines C, then A functionally determines C. Okay. Again, if you have doubts, think about it. Again, think about it. Okay, think about it. You can take an example. If you have doubts, you must come up with a count example. ඒක තමයි ඊළඟ කතන්දරය හරි. So if you can't, if you feel like this is not correct, so then you come up with a count example. එතකොට ඔයා මට count example එකක් දුන්නොත් මට කියන්න පුළුවන් මටවත් එක ඒ discussion එක ගෙනියන්න පුළුවන්. හැබැයි නිකම්ම කිව්වොත් මට තේරෙන්නේ නැහැ මේක ප්‍රත්‍යක්ෂයි නේද මට තේරෙන්නේ නැත්තම් මට කියන්න තියෙනවද? ඔය තව ටිකක් යන්න තේරෙයි කල්යයි. හැබැයි ඔයා මට count example එකක් දුන්නොත් මට පුළුවන් දිගට ඔයත් එක discussion එක ගෙනියන්න. ඔයා කියන නෑ මට හිතෙන්නේ මේක වැරදි කියලා. මට හිතෙන්නේ මෙන්න මේ වගේ තැන්වල ඔක හරියන්නේ නැහැ. So then let's discuss. Okay. I will give example. NIC functionally determines, say, department ID. If I know the NIC, මගේ data දිහා බලලා මට කියන්න පුළුවන් මෙයා ඉන්නේ මේ department එකේ කියලා. Say I have the employee table. Because NIC is my primary key, it has a department ID. Now let's say department ID functionally determines department name. Because in the department table, I have the department ID and department name. So department ID function determine department name. So therefore, I can say NIC functionally determines department name. If I know the NIC, I will specifically say this guy is in this department. Because NIC function determine department ID function determine department name. Okay. And again, what pay the IR key character. So this is possibly a primary key. And this is a foreign key. And this foreign key is a primary key here. Right? But හැමතිස්සෙම මේ වම් පැත්තට එන්නේ මොනවාද? Primary key. අන්තිමට කැරකිලා ගියාම. ඒකයි තනිකර primary key foreign key වලින් relationship හදලා. So according to transitivity rule, then we can start from one end and find out all the details about that record. NIC එකෙන් පටන් ගත්තට පස්සේ යාගේ විභාග ප්‍රතිඵලයි අරවයි මෙව්වයි කසාද විස්තරයි ඔක්කොම ටික හොයාගෙන යන්න පුළුවන් බැංකු විස්තරයි. දැන් මේ දවස්වල ආණ්ඩුව කරන එක වැඩක් නෙවෙයි නේද? ඔය සිස්ටම් එක හදාගන්න තමයි හදන්නේ දැන්. හරි. විශේෂයෙන් බැංකු වලට කනෙක්ට් කරගන්න. බදු ගන්න. දේපොළ ටිකයි ඔක්කොම හොයාගන්න විදියක් හොයාගන්න ගන්න. මට මෙහෙ වතු තියෙනවා. මේ ෆික්ස් ඩිපොසිට් තියෙනවා. හරි. මේ ඉඩම් ටික ගෙවල් කුලියට දීලා තියෙනවා. ඔය ටික හොයාගන්න බැරි දෙන හැම තාක්කල් හැමදාම ඉතින් පරිප්පු වලටයි ආල්මැස්සන්ටයි බදු ගහන්න. ඔක හොයාගත්තට පස්සේ හරි. ප්‍රශ්න භාගයක් 20 දෙන්න. Right, so that is called transitivity. දවල් දෙනවා මේ database පිළිවෙත අවුලක ඉන්නවා කියලා රජේ. හරියට normalize වෙච්ච database එකක් නෑ ආණ්ඩුවට. ඒක තමයි ලෝක බැංකුව කියලා තියෙන්නේ මේක හදාගන්න ඉක්මනට. මේ මගුල කරන්න බෑ හැමදාම හිඟන්න වගේ ණය දීදී ඉන්න බෑ. ඔය තමයි දීලා තියෙන කොන්දේසි. එකක්. database එක හදාගන්න කියලා. database එක හදාගන්න කිව්ව ගමන් එළියට පයින්නවා. පාට පයින්නවා දඩබඩ ගාලා. එහෙම කොහොමද? ඒ වගේ තව database එකක් හදන්න හැදුවා එකපාරක්. ඔක්කොම ඉඩම් වල digitize කරන්න හැදුවා. digitize කරන්න හැදුවා නිකන් මුළු ලංකාවේ ඉස්සර තෝරගත්ත ප්‍රදේශයක. ඔක්කොම digitize කරලා දෙන්න අපි කියලා. ඔක්කොම lowest ටික එළියට බැස්සා. මෙන්න ලංකාවේදී දෙකට බෙදනවා. ඇමරිකාව අල්ල ගන්න හදනවා නේද? නොදන්න මගුල් කියවනවා. database එක හදනවට විරුද්ධයි ඒගොල්ලෝ. database එක හදුවට පස්සේ නඩු නැහැනේ. ඉඩම් නඩු නැහැනේ. digitize කරාම නේ. Right. So third axiom says if a function determine actually what we will be using is first and second. අපිට වැදගත් වෙන්නේ මෙන්න මේ දෙක විතරයි අතරම. Reflexivity, transitivity. But because Armstrong axioms include 3 more, we'll just mention these 3 also. But when we are doing designing, we will be only using reflexivity and transitivity at your level. But anyway, let's look at the other 3 axioms. Union axiom says if a function determines B and a function determines C, that is a function determines B and a function determines C, then a function determines BC. BC means basically B comma C. For example, NIC functionally determines first name. NIC functionally determines second name. So therefore, I can say NIC functionally determines first name, last name. So අපි NIC එක දන්නවා හරියටම කියන්න පුළුවන් නේද? මෙයා නිමල් පෙරේරා. මෙයා කමල් ෆර්නෑන්ඩෝ. So this guy is Kamal Fernando. This guy is Nimal Pereira. So that means since NIC function determines first name, NIC function determines second name. So therefore NIC function determines first name, last name. Okay. A function determines BC or B comma C. That is called union axiom. So the next one is if A function determines B, then A comma C function determines B comma C. Okay, because C is a common thing. Okay. For example, if someone says NIC functionally determines, okay, salary, say it's employee table. So මේකට දැන් තාම මොනාරි හේතු කරලා කියලා කමක් නැහැ. Say NIC and say email functionally determine salary and email. ඒක කරා කියලා වැරද්දක් නැහැ නේ. මේක එච්චර වැදගත් නෑ අපිට. So we call this augmentation. So this is not very important one, but anyway, Armstrong axioms include that also. ඒක වැරද්දක් නැහැ ඉතින්. ඒක අපිට එච්චර ඕන වෙන්නේ නැහැ because it's obvious thing. So the projectivity is also important. That is, if A functionally determines B comma C, so then we can say A functionally determines B. A කියන එක මේ B සහ C දෙන්නවම functionally determine කරනවා. ඉතින් අපිට තනියෙන් කියන්න පුළුවන් A functionally determine B C කියලා. For example, if NIC determine your full name, which consists of first name and last name, so then I can say NIC determines first name, NIC determines last name, because NIC determines full name. Okay. ඒක ඇවිල්ලා මේ මේකෙම අනිත් පැත්ත ඇත්තටම හරි. මේකෙම අනිත් පැත්ත. If A determines B, C, that means A determines B and A determines C. ඔන්න මෙතන ලියන්න and A determines C කියලා. Right. So what we really need is reflexivity and transitivity laws. Okay. But other three rules are also not rules, basically those are the axioms are also correct. So reflexivity and transitivity are the widely used axioms. So what we mostly use axiom. So I have given you some examples. So first name determines first name, salary determines salary, that is reflexivity. Student number determines sport group determines group color. So that means student number determines group color. Right. So this is another example I explained. Right. So now we look at another concept called closure. The closure. So what is mean by closure? So now we try to build it as a theory or abstract concept. Abstract concept. These functional dependencies. So if X is an attribute, X closure we represent as X star is set of attributes derived by applying Armstrong axioms. So that means you write down all the attributes that X can derive. And if you know X, all the attributes that X can derive, we call that X closure. So how do you derive those attributes? By using Armstrong axioms. Reflexivity, transitivity, right, union and so on. But mostly we use reflexivity and transitivity only. So that is called X closure. Okay. So let's take an example. Say we have three concepts, like let's say three attributes A, B, C. A, B, C. And assume we know these things by our domain understanding. Say A functionally determine B. B functionally determines C. Now I need, let's say I need A closure. A closure means all the attributes that A determine. Okay. So what is the first attribute A determine? A determine A. Why? Reflexivity rule of Armstrong's reflectivity rule. Because A determines A. If I know first name, I know first name. If I know salary, I know the salary. So therefore, A functionally determine A. If someone asks why, reflexivity. Then they have given you. මේක දීලා තියෙනවා. ඒක අපි හිතුවේ business domain එකේ තියෙන rule වගේ. A determines B. So therefore, A determines B also. Okay, A determines B because it is given to us. So therefore, now A determines A and also A determines B. And we know that you have given that A determines B and B determines C. If A determines B and B determines C, we know that by transitivity A determines C. So therefore, A closure is A, B, C. So that what is meant by A closure? all the attributes that A determines. So what are the attributes that A determines? A by reflexivity, B by transitivity, B by, because B is given, C by transitivity, right? C by transitivity, because this is all just given. A determines B. Okay. So A by reflexivity, B directly given, C, because these two are given, then we apply the transitivity. Yes, A determines C. So that is A closure. Any question? Okay. Right. So this is an exercise. Can you find A closure? X කතාව අමතක කරන්නකෝ. Can you find A closure? ටක් ගාලා හොයන්න. උත්තරේ බලන්න නැතු. So this is given. A determines D, D determines B, B determines C, E determines B. So can you find A closure? All the attributes that determines by A. Oh. You can put it into chat. By reflexivity, A determine A. Then it says A determine D. Therefore, A determines D. And here you can see A determines D and D determines B. By transitivity, A determines B. And now you can see A determines B and B determines C. So therefore, A determines C also. Okay. And that's it. That's it. So therefore, A determine A, B, C, D, but A does not determine E. But definitely A determine A, B, C, D. Okay. A, B, C, D. Anyone got A, B, C, D? Yeah, A, B, C, D, correct. Okay, A determine A, B, C, D. Now, can you do B closure for this one? Same question. Can you find B closure? So by reflexivity, B determine B. Okay. And here you can see that B determines C, therefore B determines C. And that's it. So therefore B closure is B and C. And B closure is B and C. Now can someone find what is E closure? E closure. You need to find E closure. There are two answers. Which one is correct? Which one is correct? I can see two answers, two different answers. Okay. So by reflexivity, E determine E. Right? So then we have these rules, E determine B. So therefore, E determine B. And here you have B determine C. So therefore, E determine B and B determine C. Therefore, by transitivity, E determine C. And that's it. That's it. We can't say anything else. We can't say anything else. So therefore, E closure is EBC. So this is a very interesting thing. Right? This is a very interesting thing. Root cause analysis කරද්දී ඔක ඕනේ නෝ අපිට. Root cause analysis කරා. සාමාන්‍ය ජීවිතේ. මේ දැන් database වලට පාවිච්චි කරන හදන්න. Primary key හොඳම primary key එක හොයාගන්න. Okay. Right. Now let's see what is mean by key. Of course, you know the definition of key, primary key, right? So primary key is used to uniquely identify a record in a table. Yes, that is correct. But now we want to define primary key in a much more theoretical manner, conceptual manner. So that is why we say the relational database is based on relational theory. Relational theory is something like Boolean theory, algebra theory, Boolean theory, set theory. So mathematicians, computer scientists had built a theory. to understand these data. So we call it relational theory. යෝක තව extend කරනවා ඒගොල්ලෝ information theory security පැත්තට අරන් යනවා. So when it comes to data science, so this is the concept that move forward. So then you can add artificial intelligence. But this is the starting point. Relational theory. Right. So according to relational theory, now we want to define primary key in a much more abstract level, conceptual level. Rather than saying a primary key is the field that we use to uniquely identify a record. Of course, that definition is perfectly correct, but that is at concrete level, not conceptual level. But sometimes we need to have that conceptual understanding. ඒක හරියට physics class එකේ ඉගෙන ගන්නවා. F සමානයි ma, v සමානයි ut නේද? pv සමානයි k ඇවිල්ලා practical time වල. හැබැයි pure maths වල ඉගෙන ගන්නවා මේක relations, functions, calculus, matrices කියලා. So that really useful. ඒක ආයෙ ඉගෙනගෙන ආයෙ physics class එකට ගියාට පස්සේ physics class එකේ තියෙනවා ඊට වැඩි හොඳට තේරෙනවා. ඒත් අයින්ස්ටයින් ඇවිල්ලා එක පැත්තකින් physics කෙනෙක් අනිත් පැත්තේ mathematician කෙනෙක්. So නිව්ටන් එක පැත්තකින් භෞතික විද්‍යාඥයෙක්. හැමෝම කියන්නේ නිව්ටන් තමයි භෞතික විද්‍යාඥයෙක් කියලා. කවුරුත් කියන්නේ නිව්ටන් තමයි ඔය ඔක්කොම කලනේ කතන්දර ටික හොඳට ඕගනයිස් කරලා දුන්නේ කියලා. කැල්කියුලස් වල පියා කවුද කවුරුත් දන්නේ නැහැ නේද? නිව්ටන් වි ලිබ්නීසු. ඒතර හොඳ භෞතික විද්‍යාඥයෝ බහුතරය හොඳ mathematicians. හොඳ නෙමෙයි නිකන් එලකිරි mathematicians. ඒගොල්ලෝ ඇත්තටම ඉස්සෙල්ලා හොඳ mathematicians පස්සේ භෞතික විද්‍යාඥයෝ. Right, so this is how you define key using relational theory. The minimum set of attributes that fully functionally determines all the attributes is a key or candidate key. So this is actually much better definition, much stronger theoretical definition. So what is key? ඔයාට PhD එකක් කරනවා නම් data science පැත්ත ඉස්සරහට යනවා නම් abstract level එකේ analysis වලට මේ definition එක තමයි හොඳම definition එක. So a key or candidate key is minimum set of attributes that fully functionally determine all the attributes. So you must find the minimum set of attributes that fully functionally determines all the attributes in that concept or entity. So then it's a candidate key. If it is not, it is not a candidate key. That means if a particular combination of keys does not fully determine all the attributes, it is not a candidate key. If it is not minimal, again, it is not a candidate key. It's a super key then. අපි අර super key කියන එකට දැන් ආයෙ එනවා තව චුට්ටක්. ඕගොල්ලෝ හිතන්නේ මොකද්ද මේ super key කියලා නාටකම් නටන්නේ මේ primary key වහගත්තම මදිද කියලා. නෑ ඒව theoretically මෙහෙම තමයි යන්නේ ඉස්සරහට. මොකද ඉස්සරහට ගියාට පස්සේ මේ database එකේ primary key තීරණය කරන එක computer එකෙන් කරන්න පුළුවන් වෙනවා මේ theory වලින්. එයාට theory එකක් ඕන. අපිට program කරන්න. එතකොට එයා මේ functional determine කරලා Armstrong axioms දාලා එයාම primary key එක හොයාගන්නවා. ඊට පස්සේ එයාම කියවට මෙන්න database design එක. දැන්ටමත් AI වලට පුළුවන් කරන්නේ. අපි requirement ටිකම AI එක දෙනවා ER diagram එක. උදේට කාට හරි කියනවා මගේ ජොබ් එකට කෙලවෙනව නේද කියලා. නෑ ඔයාගේ ජොබ් එකට කෙලවෙන්නේ නෑ. ඔයා හදලා දුන්නට මොකෝ අපි මිනිස්සෙක් ඉන්නෝනේ හරිද කියලා බලාගන්න. මොකද AI වලට වරදිනවා. හරි. AI වලට වරදිනේ ඔයන්න කියන්නේ ඔයා ඊට වැඩිය මොලකාරයෙක් වෙනවා. AI ජෙනරේට් කරලා දින දෙන්නේ කොහොමද? සමහර හිතනවානේ මේ AI අපේ ජොබ් නැති කරනවා නෑ AI ජොබ් නැති කරන්නේ නෑ. මොලකාරයන්ගේ ජොබ් නැති කරන්නේ නෑ. මොලකාරයා ඉන්න ඕනේ AI එකට උඩින්. Right, so let's take an example. So we want to find what is the primary key or what are the possible candidate key for this particular database or table. Okay, so but we know these functional dependencies. What are those functional dependencies? A functional determine D, D functional determine B, B functional determine C, and E function determine B. Now your task is find the candidate key or candidate keys. Then we have student numbers, the first name, the last name. This is conceptual level. The level discussion. So how to do that? So you just take one by one. එක අරගෙන බලන්න. අඩුම වෙන තරමට හොඳයි. මිනිමල් එක හොයන්නේ. එක ෆීල්ඩ් එකක් තියුණොත් වැඩි ඉතා හොඳයි. ඒතකොට දෙකේ හොයන්න දෙයක් නැහැ. එකක් හොයාගන්න බැන්න තමයි දෙකකට යන්නේ. Because the definition says minimum set of attributes. Okay. Right. So let's see whether A is a possibility. A function determine A by reflexivity. A function determine D given. And D determine B, therefore by transitivity A determine B. Right? And of course A determine B and B determine C, therefore A determine C. Right? So that's it. I don't have anything else. So that means A determine A, B, C, D. So therefore can I use A as a key? No, A is not a key. Right? A determine can and even. So key is a minimum set of attributes that fully functionally determine all the attributes. But unfortunately, A does not determine D. So therefore, A is not a possible candidate key. Okay. So then what about B? B determine B. And B determines C, therefore B determines C. And it. That's it. So therefore, B is also not a key. Because E is not determined by anything else. E can determine karanne. So therefore, taking A alone, B alone, C alone, D alone is not going to work. Because they might determine some other things, but they're never going to determine D. They're never going to determine D. So therefore, what we need is no point trying B, C, D, right? But if you take E alone, what happens? Of course, E determine E by reflexivity. Then E determine B, given. And B determines C, therefore E determines C. And again we struck. I appear then. E determine E and E determine B. And because E determine B and B determines C, E determines C, and there's no other thing. Because we may connection. So therefore, E alone is also not going to be a key, candidate key. E අනිවාර්යෙන් ඉන්න ඕන. මොකද E ගන්න පුළුවන් එකම විදිය reflexivity විතරයි. So that means you can, by analyzing, you will feel like, okay, E must be in your candidate key. Without E, you can't build a candidate key. එහෙනම් අපි දැන්ටම අපිට හම්බෙලා තියෙන A කියලා එක්කෙනෙක්, එයාට අනිත් ඔක්කොම හරි E විතරයි නැත්තේ. ඔක්කොම හරි E විතරයි නැත්තේ. දැන් මොකද කරන්න ඕන? අපි මේ A ට E දාමු. A and E, because A determine A, B, C, D, and E determine E by reflexivity. So therefore, A is a possible candidate key. A is a possible candidate key. Because single field is not going to work. Because A, B, C, D, none of those are going to work. Because none of those are going to determine E. E alone doesn't work because E determine B and B determine C, and that's all. So therefore, we have already found that A determine everything other than E. So therefore, let's add D. So then A determines this, but this is just a candidate key. So then maybe there are some other candidate keys, maybe C and E, I don't know. Of course, A and E, B and E is not going to work because then B is BC, then B is BCE. Okay. So what about C? C determines only C. C C so C A B C what about D? So D D determine D, then D determine B, and B determine C, right? And that's it. Right? So therefore D determine D, B, and C. So if I add D, I A A. So therefore, single combination, single attribute doesn't work. two attributes. Out of the two attributes combinations, A is working. So therefore, there are few double combinations. Then two attribute combination. Out of those two attribute combination, only A is working. So therefore, now we can stop and say A is the candidate key. Actually, okay, because no need to go for three attributes, because what we need is minimum set of attributes. So therefore, when I already found two attribute combination, which is a candidate key, I don't have to find three attributes, because key must be a minimal set of attributes. Right? So now, therefore, I have found my possible candidate key. Of course, final thing එක කරන්න ඕන designer business rules කල්පනා කරලා බලලා අනිත් ඒවා කල්පනා කරලා එයා decide කරයි සමාන මේක තමයි primary key එක විදිහට ගන්න කියලා. Okay. So A is a candidate key. This is a very interesting topic. Okay. So you can see these are all possible candidate keys, but this is the minimal. Okay. So therefore A is the minimal that fully functionally determined. හොඳට මතක තියන්න ඡන්ද ලං වෙනකොට මේ ෆන්ක්ෂනල් ඩිපෙන්ඩන්සි කතන්දරේ එළියට බයින. ඇයි ඒ? ඔක දන්නවනේ දැනටමත් තියෙන ප්‍රොක්සි කැන්ඩිඩේට්ස්ලා. හරි ප්‍රොක්සි කැන්ඩිඩේට්ස්ලා. හරි ප්‍රොක්සි කැන්ඩිඩේට්ස්ලා කොහෙද කරගෙන්නේ මේ දවස්වල? නේද? එක්කෙනෙක් ඉන්නවා කවුද? අර දෙරණේ අයිතිකාරයා ඉන්නවා. නේ දෙරණේ අයිතිකාරයා ඉන්නවා. ප්‍රොක්සි කැන්ඩිඩේට් කෙනෙක්. එයාට ඉන්නවා සෙට් එකක් ඉන්නවා ඡන්ද ටිකක් තියෙනවා. නේ දෙරණ බලන ඡන්ද ටිකක් තියෙනවා බයි ඡන්ද ටිකක්. හරි ඒ ප්‍රොක්සි කැන්ඩිඩේට්ලා ඒගොල්ලන්ට තියෙනවා ඡන්ද. හරි. ඒතකොට ඒ ඡන්ද සමහරට මේන් එන එකකට ඒ ඡන්ද නැහැ. නේ ඊළඟට ඉන්නව කවුද? තා කවුද ඉන්නේ? තා කවුද ඉන්නේ? මට මතක නැහැ නම් මතක නැහැ මේ එක එක එවුන්ගේ. අර තව සල්ලිකාරයෙක් ඉන්නව නේද? ධම්මික පෙරේරා ඉන්නවා. මිනිහට ඡන්ද ටිකක් තියෙනවා. හරි. එහෙනම් තව කවුද ලංසා දාගෙන ඉන්නවා. මෛත්‍රීලා ඔය අටෝ ගන්න ඉන්නේ නේද? මෛත්‍රී පාල සේනානායක මරා ගන්න දැන් ඔය ඒ ඡන්ද ටිකක් තියෙනවා. පට්ටියක් ඉන්නවා එතන. එක එක පට්ටි වල කට්ටිය. අන්තිමට 150 හදා ගන්න නම් ඔය පට්ටි ටික ඕන වෙනවා. අර එහෙන් උතුරු නැග කඳුරට ඉන්නව නේද? තොණ්ඩමන් ඉන්නවා. උතුරු නැගෙනහිර සම්බන්ධන්ලා ඉන්නවා. අන්තිමට මේගොල්ලෝ බලනවා මේ ප්‍රධාන කැන්ඩිඩේට්ලා මම කවුරු එක්කද සෙට් වෙන්නේ? මට තාම 50 නැහැ. මට තාම 50 නැහැ. අනිත් අතට මේ ඔක්කොමල් එක්ක සෙට් වෙන්න කිව්වොත් මගේ බලය මේ කැඩිලා යනවා. එතකොට ඒගොල්ලෝ බලනවා මිනිමම් මම කවුද සෙට් කරගන්නේ මගේ පැත්තට? මිනිමම් 50 දාගන්න. අන්තිමට 50 දෙන්නවා. ඒතකොට ඔය ප්‍රධාන දෙන්නෙක් ඉන්නවනේ දැන් රනිල් ඉන්නවා, සජිත් ඉන්නවා, අනුරු කුමාර ඉන්නවා. මේගොල්ලන්ට සිද්ධ වෙනවා 50 නැති වෙනකොට මොකද 50 නැහැනේ බලාගෙන ගියාම තමන්ගේ පට්ටි ටික එකතු කරලා බලනවා ඊට පස්සේ. පට්ටි ටික එකතු කරාට පස්සේ 50 නැහැ 150. 150 නැතුණාම බලනවා දැන් මම කවුද සෙට් කරගන්නේ? මොකද මෙයාටත් පට්ටියක් තියෙනවා. ඒ පට්ටිය එකතු කරාම මට 50 දෙනවනේ අපි දෙන්නම එකතු වෙදලා එක සන්දානයක් වෙනවා. ඔන්න ඔබ දැන් පොලිටික්ස් වැඩ කරන්නේ. හරි? පොලිටික්ස් වැඩ කරන්නේ. ඒක තේරුම් ගන්න ඕගොල්ලෝ හරියට මේ ලොජික් ඉගෙන ගන්න ඕන, ෆන්ක්ෂනල් ඩිපෙන්ඩන්සි ඉගෙන ගන්න ඕන. ඒක තමයි පස්සේ ඩේටා සයන්ස් කියලා ඉස්සරහට යන්නේ. AI කියලා ඉස්සරහට යන්නේ. හරි. 50 හදා ගන්න ඕනේ ඊට පස්සේ ඒගොල්ලෝ. 50 හදන්න ඕනේ කැල්කියුලේෂන් එක දැන් කරනවා ඒගොල්ලෝ ටික ටික. ඡන්ද ලං වෙනකොට. හරි. ඡන්ද ලං වෙනකොට. ෆන්ක්ෂනල් ඩිපෙන්ඩන්සි. මොකද මේවා සමහරට ඉන්ඩිපෙන්ඩන්ට් සමහරට Aට ඉන්ෆ්ලුවන්ස් කරන්න පුළුවන් වුණාට Dට Aට ඉන්ෆ්ලුවන්ස් කරන්න බෑ ඊව. ඒකට ඊව ඉන්ෆ්ලුවන්ස් කරන්න එක්කෙනෙක් එයා කම්බයින් කරගන්න. මොකද ඊට යාට ඉන්ෆ්ලුවන්ස් කරන්න බෑ සමහරට Aට. ඒ වෝට් බ්ලොක් එකට. So these are very interesting topics, okay? Very interesting topic. Logic කියන්නේ හරි මේ data science කියන්නේ ආයේ එල කිරි වගේ සබ්ජෙක්ට් හරියට ඉගෙන ගන්න හරියට ඉගෙන ගන්න නැහැ නිකන් බොරුවට විභාග පාස් කරලා කරප්පට්ටිය වගේ ඉඳලා වැඩක් නැහැ. Right, so this topic I will cover later because this is advanced topic, so you need little bit of time to understand this functional dependency, what is closure, what is primary key, what is mean by minimum combination that fully determine all the attributes and so on. Okay, but now let's move on to, so we will come back to this next class. That is what is mean by lossy decomposition. Okay. Right. So now we move on to normalization. Normalization of data. So what is mean by normalization of data? So we have something called first normal form, second normal form, third normal form, boycott normal form, right? And as when we design database, part of the designing process is normalize your database. Make sure that your final relational database schema is normalized, at least up to third normal form. Okay. So if the database is normalized, that means it is good design. Good design. If it is not normalized, that means you find that first normal form is violated, second normal form rules are violated, that means your design is not good. You are going to have some troubles when you are using it. Okay, so that is the idea behind normalization. Right. So as I told you, normalization is a mechanism or approach where we try to see whether our database design is properly done. If not, we refine it so that it complies with normalization rules. Okay. Now, when you are new to database designing, of course, most of you guys are new, right? So after you design, right, you know that we need to introduce how to model one-to-one relationship, one-to-many relationship, many-to-many relationship. So how to model union relationship, binary relationship, ternary relationship, and so on, right? And how to work with weak relationship, weak entities. Okay. Now you know all these theory, what to do with composite attributes, what to do with uh, derived attribute, what to do with multivariate attribute. Right? So you know these things, and using that knowledge, you will design your ER diagram or you design your database design. Right? So if you are a very experienced designer, that means very competent, experienced designer, usually what happens is once you design your database, and if you check whether your database is in first normal form, second normal form, third normal form, and so on, you will find that yes, they are. Right? Yes, they are in normalized, because when you do the designing, if you do it properly, definitely your database is already normalized. Okay. But anyway, it's good to double check. But if you are new to database designing, right? So that is the case for most of you guys. So then there's a possibility, because then you are not perfect. If you guys are perfect, all of you guys are going to get A's, A pluses. Right? So there will, but then when you again look at it through the normalization mechanism, if you have make any mistakes, or if you have done not a very good design, so those things will be detected. And you will find that, okay, this is not in first normal form, this table is not in second normal form. So then it's another opportunity for you to fix those issues. Okay. For experienced designers, just to double check. Most of the time, they will find that yes, they are in normalized form. For new designers, this is a very good opportunity to find issues and fix it. And when you fix those issues, that is, you find that it is not in second normal form, you fix it. So when you fix it, you learn it from that. And maybe next time when you do a designing, there's a higher chance you design it in a proper way so that it's not violated in the second normal form. So therefore, it's a good experience for you to improve yourself as well. Okay. Right. So normalization is also done as part of the logical designing. Okay. So if you have a properly normalized logical design, that means it has very little redundancy and all the integrity is maintained, or major integrities are maintained. So it's a sequential approach. Sequential approach means we do one and then go to the second one. One after the other. There's a sequence. So first we check whether it is in first normal form. If it is in the first normal form, you go to the second normal form. Otherwise, you fix it. Fix it to the first normal form. If it is in the first normal form, only you go to the check second normal form. If there are issues, you fix it. So that now it is in the second normal form. So then you check the third normal form for and so on. It's a sequential process. You can't say that, okay, first I will check the third normal, then I will check the first normal. No, that is why even they have given the numbers. First normal form, second normal form, third normal form. Okay, it's a sequential process. So what are the major concepts behind normalization? First concept is atomicity. Second concept is functional dependency. That is why we discuss functional dependencies before starting this. Especially when it comes to first normal form, so the concept is atomicity. When it comes second normal, third normal, boycott normal, the main concept is functional dependency. Okay. Right. So we'll start from first normal form. So remember, first normal form is something to do with atomicity concept. Atomicity means you can't break it further. Okay. Atom means that paramanu. Right. So what is the definition of first normal form? A relation is said to be in first normal form if all its attributes or fields are atomic. Simple as that. If all the attributes or fields are atomic, then that table is in first normal form. So you need to check it for each and every table. Right? Each and every table. So you take the first table. Is it atomic? All the attributes are atomic. Then it is in first normal form. So then next table. Likewise, if there are 20 tables, you need to check each and every table and see whether all the attributes are atomic. If it is violated, you need to fix it. So then only we say your database is in first normal form. Right. What is mean by atomic? So atomic means your field can get only one value. Simple as that. So if your field have only one value or one possible value, it is atomic. But if your field has more than one value in data wise or whatever, or if there's that possibility, then we say no, your database is not in first normal. If a database is not even in first normal form, we say that the database is in zero normal form. So basically zero normal form means it is not normal. Okay. So let's see an example. Now here you can see I have a table called customer. Fields are custom ID. Say this is someone's design. Custom ID, first name, last name, contact number. But by looking at the data, you can see there's a possibility of multiple contact numbers. So there's a possibility of multiple contact numbers, but this guy has added as a one field. So that means this particular table is not in first normal form. No, because you can see there's a possibility of multiple values. So if that possibility is there, so then someone will say, how do I know that there's multiple values? So that is why you need a system analysis. So that is why you need to ask from the customer, is there a possibility of more than one contact numbers? Okay. For example, if it is a customer relationship management system, of course, there's a high possibility the same customer provide you more than one contact number. Saying that this is my dialog number, this is my Mobitel number. Sometimes this doesn't work. If so, call me in this. Then we can't say no, we can keep only one number. Okay. So then it is if you have a field for that, and if there's a possibility of multiple values, it is not in first normal form. So then what is the solution? Right? So you identify the problem that it has violated first normal form. Now you need to fix it. There must be a solution. So basically the problem is this is a multi-valued attributes. For the multi-valued attributes, you have assigned a column. So therefore now you need to fix it. First of all, get rid of this field. This field, you can't have it here. So now you can see that customer table, you have only customer ID, first name and last name. Okay. Because there's multiple possibility of multiple values. Your task is introduce another table for this and map it as one-to-many relationship. Right? One-to-many relationship. Now we have the customer table and we have another table and it is related as one-to-many. So we can call it customer contact or whatever. And this is the many side. So therefore foreign key comes here. And foreign key is the same as the primary key here. And therefore now we can see customer ID 1 has this phone number, customer ID 1 has this phone number. Customer ID 2 has only one phone number, but customer 3 has again two phone numbers. Even you can, in this scenario, when you design like this, a customer can have even 100 phone numbers. Of course, practically it won't happen, but still it supports. So now you can see that this has violated first normal form, and this is the solution. Introduce another table and map it to the original table using one-to-many relationship. So other table you can have its own primary key. Or you can use your foreign key and this field as composite primary key. May composite primary key with use karna pula. Third surrogated primary key ka dan pula machine generate key ka. 1, 2, 3 කියලා sequence එක හදාගෙන ඒක අපිට වැදගත් නැහැ. Okay. මේ වගේ දැන් ඔය ගොඩක් අර surrogated key තමයි use කරන්නේ. But the other option is you take this combination as the primary key, then you don't need to go for surrogated machine generated primary key. Right. Any question about first normal form? ඔයා software developer කෙනෙක් විදියට job එකකට ගියොත් ඉතින් අනිවාර්යෙන්ම ඔයා කරන software එකේ database එකක් තියෙනවා. ඒක බොහෝ විට relational database එකක්. ඒකට relational database එකේ ඔය කතන්දර තියෙනවා. ඉතින් ඔයා finally project එක කරනකොට අනිවාර්යෙන් ඔය database එක ඔයා design කරන්න. ඒක කවුරු design කරන්නේ නැහැ. ඒකට ඔයා බලන්න ඕනේ මේක දැන් first normal form violate වෙලාද කියලා. මේ වගේ multi value fields වලට මම column දාලාද කියලා. ඒකට practically use කරන්න බැරි වෙනවා ටිකක් දවස් ගියා. So no question, right? So there's another scenario, but that is not a very important scenario for you guys. So that is why I told this case 1 and case 2. So this is an example for a case 2. So this is a similar example. You can see that the same product has multiple colors. So some products have white product and black product. Some products have only black product, white product. So there is again issue. So you need to take it to a separate table and connect it as one-to-many relationship. So then you know that, okay, product ID 1 has only white, but if you take product 2, sorry, product 1 has 3 colors, product 2 has 2 colors, and product 3 has only 1 color. And these are the prices. අපි හිතමු දැන් color එක යනවා price එක වෙනස් වෙනවා කියලා. එහෙම වුණොත් එම් price field එක එන්න ඕනේ මෙතනට. Sometimes that can happen. Right? So සමහරවිට ඒක color එක අනුව price එක වෙනස් වෙනවා. So then price can't be here. The price must also come here. Okay. So this is you can see that issue in different way. මේ එකම ලෙඩේට රෝග ලක්ෂණ දෙක තුන එන්න පුළුවන්. එක රෝග ලක්ෂණයක් තමයි ඔයාලට පේනවා මේව මේ මල්ටිපල් වැලියුස් දානවා මේගොල්ලෝ කමාදදා කියලා. නැත්නම් එහෙම දාන්න වෙනවා කියලා. ඒකට ආය දානවා ලෙඩේ ෆස්ට් නෝමල් ෆෝම් කඩලා. මෙන්න තව ඒ ලෙඩේම තියෙනවා වෙන විදියකට අහු වෙනවා. So this is how someone has designed it. Employee ID, first name, last name. Now he has added two fields, qualification 1, qualification 2, maybe qualification 3. So then someone might say, okay, now this is fixed, that is good, right? So if you like contact number 1, contact number 2, right? Qualification 1, qualification 2. So then someone will say, okay, now that is fine, right? Now it is atomic because your qualification 1 field can have only one value. Qualification 2 has only one value. So therefore, this has not violated first normal form. But in reality, this has violated first normal form. Actually, this is a false solution, wrong solution. Because one thing is you never know how many possibilities are there. So what about if someone has 10 qualifications? Are you going to have 10 fields? So then if most of the people have only 1 or 2 qualification, so having 10 columns is waste of storage. So therefore, though this look like a solution, this is a very bad solution. The proper solution is, again, go for another table and map it as one to many. So therefore, this is again violation of first normal form. So you get the same problem, the symptoms are now different. But the solution is the same. You break it into a separate table and map it as one to many. Okay. So this is another symptom. Right? So this guy has tried to have all the product order details and order item details in one table. Order details, order item details එකට දාලා. දැන් මොකද වෙලාද? මේ පැත්තට duplicate. මේ එකම data duplicate වෙනවා. That is again violation of first normal form. පේනවද? එකම ලෙඩෙත් එක එක විදියට ඒ කියන්නේ මේ බොරු මේ වැරදි ඩිසයින්. ඒකට ඔයගොල්ලන්ට වැරදි ඩිසයින් කරන්න ඕනේ නැහැ. ඔයගොල්ලෝ හරි ඩිසයින් එක කරනවා. කාගේ හරි ඉතින් වැරදි ඩිසයින් එකක් වුණොත් ඔයාගේ ඉතින් වැරදි ඩිසයින් එකක් වුණොත් ඔයාටම අහු වෙනවා. So this is not the way to go. So you need order table separately and then one to many order item table. So therefore this is not proper design. Again, it is right. So this is not. Now you can see same purchase order number. That is your primary key. Then multiple records. මේ කොහොමද ගන්නෙත් නැහැ database එකේ error එකක් දෙන්න. So you can see මේ මෙතන නැති වුණාට මේකත් ඇත්තට 1112 වෙනවා. නේ. මොකද මේ order item දෙකක් තියෙනවා bill එකේ. So this doesn't work. So this has violated what? Again, first normal form. So the solution is have order details in order table, then order items in order item table. Right? For example, purchase order 111 has 4 items. So let it have it in the purchase order item table. Okay. So there's a question whether if you create another table, it's you need more storage. If you look at this one, yes. If you look at this one, yes, you need more storage. But storage is not our primary concern. So the primary concern is integrity. Integrity. Data හරියට neat එකට තියෙනවා හරියට තියෙනවා. And these days storage is not an issue, right? Storage කියන්නේ වැඩි ගණන් ගන්න දෙයක් නෙමෙයි දැන්. Storage කියන්නේ බොහොම ලාභ දෙයක් දැන්. So therefore, yes, sometimes you need more storage, but storage is a concern. We don't want to unduly increase storage. But you don't want to preserve storage by doing wrong things, which can get into some serious issues when it comes to querying, data analysis, and so on. Okay, so that is the idea. Right, so now we move on to the second normal form. 2NF. Remember, first normal form is the theory is atomicity. From second normal form onwards, the theory is dependency, functional dependency. Right. First, read the definition of second normal form. A relation is in second normal form if it is in first normal form, and of course, if it is not in first normal form, we don't look at whether it's second normal form. No point. Right? First, check whether it is in first normal form. So, okay. And every non-key attribute is dependent on the whole of the key, not just part of the key. Or in short, we say no partial dependencies for non-key fields. Okay. So this is mostly happen or possible when you have composite primary keys. So therefore, I will take a composite primary key table and explain it. So assume this is a table, most probably a connecting table. A student can register for many courses. Course can have many students. So this is probably the connecting table. Okay. Now this one has a composite primary key. You know that usually connecting table has a composite primary key unless you introduce a surrogated key. And look at the other fields. So the second normal form says your non-key fields must fully depends on or must depends full primary key, not just part of it. All your non-key fields must depends on full primary key, not just part of it. Okay. Now look at the payment. Does payment depends on just student ID? Then it has violated second normal form. Or if it just depends only on the course ID, it violates second normal form. But if payment depends on this combination, then it has not violated the second normal form. So that is what is mean by your non-key fields must depends on the full primary key, not part of it. Not part of it. Of course, first of all, it must depend on your primary key. And when it depends, it must, if it is a composite, it must depends on full primary key. Right. What about payment? Does payment depends only on student ID or only on course ID, or does it depends on combination of this? Okay. So payment depends on combination of this. So then someone will ask, how do you say like that? Look at the business scenario. So when a student does payment, student will say, this is my student ID. I have registered for BIT. This payment is for BIT. Maybe that student has registered for another course. Then the student will say, so this time I am doing payment for my, say, business administration course, my ILTS course. So therefore, when you do a payment, it is by a particular student for a particular course. It is not just the student came and do a payment. ඒක හරියට පුණ්‍යාධාරයක් දීලා එනවා වගේ නෙමෙයි මේ මගෙන් මේ සල්ලි ගන්න කියලා දෙන්නේ නැහැ නේ. මගෙන් මේ සල්ලි දෙන්න කියලා ඉන්ස්ටිටියුට් එකකට සල්ලි ගෙවන්නේ නැහැ නේ. මගෙන් මෙන්න මේ කෝස් එකට මේ ෆී එක ගන්න. ඔයගොල්ලෝ යුනිවර්සිටි එකට සල්ලි ගෙවනකොට නිකන් ගෙවන්නේ නැහැ නේ මේ මගේ සල්ලි කියලා නෑ. වා කියන්නේ මගේ මේ සල්ලි සෙකන්ඩ් සෙමෙස්ටර් එකේ මගේ මේ රෙජිස්ට්‍රේෂන් එකටයි මම මේ පේමන්ට් කරන්නේ. So that means for this particular student for this particular course. එතනින් නවතින්නේ නැහැ. For this particular student, for this particular course, for this particular purpose. මේක registration fee එක. මේක renewal fee එක. A level එකට යනවා එතනදී. But if you have something like course name here, and obviously you know that course name is only depending on the course ID. Course name can be determined by course ID. Right? Course name has nothing to do with the student ID. But student ID is also part of the primary key. So therefore, we can say that course name is partially depends. There's a partial dependency. because course name depends on part of the primary key, which is course ID. So therefore, having course name here is wrong. It violates second normal form. But having payment here is okay, because payment is for this student, for this course. So that is fine. And again, if you have something like student name, that is bad. So student name depends on student ID. Student name doesn't depend on course ID. So therefore, again, your non-key field depends on part of the key, not the full key. Okay. Now can someone give me an example of another field for this, which is valid field? Can you give me another non-key field for this table, student course table, which is you feel like it should be valid. It should be okay. So I don't look at the answer because I want at least 2 or 3 answers. Subject code, date of payment, payment type, right? So date of payment, yes, because this student did this payment for this course on that particular date. Yeah, I'll say date of payment. That is perfectly okay because it depends on student ID and course ID. Right? So payment type, yeah, maybe yes. Right? Payment type, yes. Correct. So what about the other answer? Subject code. Subject code. It's not a very good answer, but anyway, I can't say wrong because maybe you think in a different way. Okay, because maybe then it is related to exam. Okay, exam. Yeah, then maybe we can connect, make that connection or the relationship different way as well. But it's also possible answer, but probably we can do it in a slightly different way as well. But yes, maybe if you don't have a lot of functionalities, yes, right. So anyway, those are very good answers anyway, right? Very good answers. So because those are related, fully depends on the full function, full primary key. Okay, full primary key. Right. So that's all about. So the solution is, if you have violations like course name, just take it to the relevant table. So course name must not be here. Course name must be in the course table. So something that should be in the course table, you have taken it to the student course table. So the solution is, if you have those violations, take it to the relevant table. Take it to the relevant table. It is not, it must not be here. Okay. So this is after fixing. Now you can see that course name is in the course table. So we have taken out the course name from here because it is not supposed to be here. Right. Now we move on to our third normal form. 3NF. So the third normal form says, first read the definition. A relation is in third normal form if it is in 2NF, and of course that is why we say those are sequential. If it is not in 2NF, don't test whether it's in 3NF or not. That is not relevant. First, A game gala 2NF කරගෙන තමයි 3NF බලන්නේ. So the relation is in 3NF if it is in 2NF and each non-key attribute is directly dependent on the key. So your non-key attributes must directly depends on the primary key, not indirectly, through another field. Or in simple, we say there can't be any transitive dependencies. Dependency must be direct, not transitive. You know what is a transit? The transit එකෙන් කොළඹින් ඩුබායි ගිහලා ඩුබායි transit එකකින් පස්සේ තමයි පැරිස් යන්නේ. එහෙම බෑ. කෙලින්ම කොළඹින් පැරිස් වලට depend වෙනවා. Okay. So all non-key fields must directly depends on the primary key, not transitively depends via another non-key. If it transitively depends on primary key via another non-key field, it has violated third normal form. In simple, no transitive dependency. Second normal form, in simple, no partial dependency. First normal form, in simple, no non-atomic fields. කෙටියෙන් කියන්නේ එහෙමයි. No non-atomic fields, no partial dependencies, no transitive dependencies. But you must know the longer version of the definition as well. So if you have transitive dependency, you need to refactor it again. So basically you need to take that field to a relevant table. So it is not supposed to be here. Okay, so this is an example. Okay, say you have a purchase order number as the primary key. So then you have the purchase order date. So that is fine, right? So this particular purchase order is made on that particular date. So it depends on the purchase order number. So then the employee code. Employee code means which employee, right, register this purchase order or enter this purchase order. So that is fine, right? So we must know this purchase order is entered by this employee. So that is also fine for me. Then the supplier purchase number, supplier number. So that is correct, right? So we must know that this purchase order is from the supplier. So then what about supplier name? So can we say that this supplier name is for this purchase order? Of course, if you want, you can tell it, but in reality, what happens is this supplier name is for this supplier number. With the functional dependency and unique වෙන්න බෑ. Key එකක් කරානේ යන්නේ. So this is your foreign key. And this must be a field that depends on that. Or supplier number determines supplier name. Not purchase order number determines supplier name. So therefore, in reality, what happens is purchase order number determines supplier number and supplier number determines supplier name. So therefore, this is a transitive dependency. Or in other words, you can say supplier name depends on supplier number. Supplier number depends on purchase order number. කොයි පැත්තෙන් බැලුවත් මෙතන transitive එකක් තියෙනවා. So therefore, supplier name field has violated the normal form. So therefore, this must be taken out and it must be in the supplier table. So something that must be in the supplier table, you have taken it here. Okay. That is the solution. So now we have fixed it. Now there is no third normal form violation. It's very easy, right? It's not a rocket science. It's not at all rocket science. ගොඩක් වෙලාට ඉතින් මෙහෙම ඩිසයින් වෙන්නේ නැහැ. හරි ගොඩක් වෙලාට මේ සප්ලයි නේම එක උතන්ට එන්නේ නැහැ එක්ස්පීරියන්ස් ඩිසයිනර්ස් ලාගේ. එක්ස්පීරියන්ස් නෙමෙයි ඕගොල්ලෝ පොඩ්ඩක් සීරියස් වුණා නම් ඕගොල්ලන් ඇති මේව ජීවිතේට වයලට් වෙන්නේ. මොකද කරද්දිත් ඕ ඔළුවට එනවා ඊට පස්සේ මොකද අදන්න නේද? ඩිසයින් එක කරද්දිම ආගේ ඔළුවට එනවා third normal form එක දැන් වයලට් වෙනවා කියලා. ඒතකොට අමුතුවෙන් third normal form වයලට් වෙනවාද කියලා බලන්න දෙයක් නැහැ. ඒව ඇඟට ගියාට පස්සේ නේද? අපි වාහනයක් එලවනකොට මුලින් ඉගෙන ගන්නවා. හරි? ක්ලච් එක පාගලා ගියර්ස් මාරු කරන්න ඕන. හරි? සිග්නල් දාන්න ඕන. ඕවා ඉගෙන ගන්නවා. ඉගෙනගෙන තමයි ඊට පස්සේ පළවෙනි මාසයක් විතර නම් හිත තමයි ඕක කරන්නේ. ටිකක් දවස් ගියාට පස්සේ මාස 4-5ක් ගියාට පස්සේ වාහනෙන් නගිනවා මතකයි වාහනෙන් බහිනවා මතකයි. මොකද්ද මන් දන්නේ නැහැ කොහොමද ගෙදර ඇවිත්. මං කියන්නේ ඒ වගේ එහෙම කියලා රෙක්ලස් විදියට drive කරන්න කියලා. But it become part and parcel of your life. Part and parcel of your life. ඒක අර ඇවිදිනවා, hina වෙනවා, කතා කරනවා වගේම drive කරනවා ඊට පස්සේ. So then එතකොට ඔයාගේදී violate වෙන්නේ නැහැ. හිතලා gears දැම්මේ නැති නට ඔයා gear මාරු කරනවා. ඔයා හරි වෙලාවට signal දානවා. මං කියන්නේ ඩිසිප්ලින් කෙනෙක් නම්. ඒ වගේ තමයි ඩිසයිනර් ඔයා සීරියස්ලි මේ සබ්ජෙක්ට් ඉගෙන ගන්නවා නම් මේ සීරියස් සබ්ජෙක්ට් ඉගෙන ගත්තට පස්සේ ඔයා කරන හැම ඩිසයින් එකේම ওই normalization violate වෙන්නේ නැහැ. හැබැයි ඔය serious කෙනෙක් නම් විතරයි යා. Right. So that is what is mean by third normal form. Okay. So this is another example. So book ID, book name, publisher. So who published this particular book? And then you have the contact number. So basically contact number is publisher's contact number. So book ID determines book name. Book ID determines publisher. But we can't say book ID determines the contact number of the publisher. Make a pote contact number can mean publisher contact number. So therefore, so there is a transitive dependency. So therefore, this must be having the publisher or the publisher ID. Contact number must go into the publisher table. Right? Ideally, here you must have the publisher ID. Right? අන්න වරද්දලා තියෙනවා නේද? මට contact number එක මෙතනින් ගලවන්න අමතක කරලා. මම ඒක fix කරනවා. So මේක අයින් කරන්න ඕන. මේක අයින් කරන්න මට අයින් කරන්න අමතක කරලා. පේනවා. මේ contact number එක අරයට ගෙනිහිලා තියෙනවා. මට මෙතනින් අයින් කරලා නෑ. හරි. So I'll fix it. මොකද modify කරලා ආයෙ upload කරනවා. ඊට දෙනවා දෙපාරක් code නැහැ කියලා contact number එක. Right. So this must be removed and taken here. Or it must be in the publisher table. Okay. Right. Further normalization. So usually when you design a database, even in profit, when you are developing commercial software, usually we care about only first, second, and third. අපි සාමාන්‍යයෙන් තුන්වෙනි normal form එකේ හරියට කල්පනා කරන්නේ නැහැ. ඒක industry එකෙත් එහෙම තමයි. Okay. Unless there is a very specific requirement or we are having some special issues. But as a theory, sometimes it can be useful as well. So computer scientists, software engineers, they have developed 3 more normal forms. Boycott normal form or BCNF, sometimes people call it 3.5 normal form, fourth normal form and fifth normal form. Most of the time, actually, you don't have to do this. Sometimes doing fourth normal and fifth normal form introduce unnecessary complications. And remember, one of you mentioned that when you break it to another table, it needs more storage. Yes. But for the first normal, second normal, third normal, that additional storage is worth. But a lot of software developers feel for fourth and fifth normal form, if you do that like that, that is sort of a worthless, and still it take more storage also. So that is why we don't even learn about fourth and fifth. But just remember, there are concepts related to fourth and fifth. BCNF is not something we really interested, but anyway, it's mentioned in your note. So therefore, we will briefly look at BCNF or boycott normal form. Boy's code normal form. Sometimes we call it 3.5. So Boy's code means the name of the people who came up with this normal form. Proposed this normal form. Okay. And this is little bit difficult to understand because this is relevant when there's a very specific scenario. 3.5 නැත්නම් BCNF එක ඕන වෙන්නේ ඉතාම specific usage scenarios වල විතරයි මේක අපිට අවශ්‍ය වෙන්නේ. නැත්නම් මේක අපිට ප්‍රශ්නයක් වෙන්නේ. So let's look at what is that usage scenario, and if you have this kind of a 3.5 NF issue or boycott normal form is violated, how to fix it? And again, this is very rarely used. Okay, very, very rarely used. In the industry, usually we don't care about this unless we have this kind of a very special requirement. Okay, right. So this is the informal definition of boycott normal form. Each attribute must represent a fact about the key, the whole key, and nothing but the key. මේක හරි ලස්සන definition එකක් අන්දම මම දැම්මේ. හරි? හරි ලස්සන definition එකක්. හිතන්න පුළුවන් අයට. Right? Each attribute must represent fact about the key. ඔයාගේ තියෙන අනිත් හැම ඔයාගේ තියෙන normal තියෙන attribute ගත්තොත් එහෙම ඒවා අනිවාර්යයෙන්ම මේ හැම attribute එකම අනිවාර්යයෙන්ම අර key එකත් එක්ක සම්බන්ධ වෙන්න ඕන. key එකෙන් කියන දෙයක් වෙන්න ඕන. The whole key. ඒක මුළු key එකට සම්බන්ධ වෙන්නත් ඕන. nothing but the key. හරි ඕක key එකට සම්බන්ධ නැති දෙයක් වෙන්න නොවෙන්නත් බෑ. වෙන්නත් බෑ. ලස්සන වාක්‍යයක් ඒක. හරි. whole key වෙන්නත් ඕන. බාහිරට වෙන්නත් බෑ. ඒකටම වෙන්නත් ඕන. ඒ වෙන කුටපටයක් වෙන්නත් බෑ. So that is the informal definition. The informal definition මේව නම් formal definition එක හිතා ගන්න පුළුවන් නේද? Right, this is the formal definition. ඉතින් මේක තේරෙන්නේ නැතුනට එච්චරම බය වෙන්න එපා. හරි මේක සමහර එක්සෑම් එකට ඕන වෙන්නේ නැහැ අපිට. මම හිතන්නේ එක දවසක්වත් එක්සෑම් එකේ අහලත් නැද්ද කොහෙද? සාමාන්‍යයෙන් software design කරන්නේද ඕනේ. හැබැයි ඉතින් මේක තේරුම් ගන්න බැරිත් නෑ. කල්පනා කරාම තේරෙනවා. but මේක සමහරට එකපාර තේරෙන්නේ නැහැ වට. සතියක් මාසයක් ගිහිල්ලා තමයි තේරෙන්නේ. Right, so this is a formal definition. A relational scheme R is considered to be BCNF. Of course, if it is in third normal form, ඒ කියන්නේ මම දැම්මේ නෑ දැන් පූජාව කිව්වනේ. හරි BCNF බලන්නේ 3NF නම් තමයි ආ. එතනින් එහා ටික. For every one of its dependencies x determine y, one of the following condition holds true. X determine y is a trivial functional dependency. That is, y is a subset of x. X is a super key for schema R. Okay. I know that still things are not very clear, or maybe you are getting more confused now. So the best way to understand this is take an example. Example in the තේරුම් ගන්න ලේසි. මොකද මේ definition කියනකොට මුල කියනකොට අග කියනකොට මුල මතක නැහැ. Right. So let's take an example. මේ example එකේ තේරුම් ගන්න ඊට පස්සේ ඔය definition එක ඕන කියවලා බලන්න. Say I have this particular table. Student, course, instructor. Okay. Let's assume this is our only table. මේ table එක විතරයි අපි ගාව තියෙන්නේ. මුළු data වලට ඔය table එක විතරයි ඔක්කොම data තියෙන්නේ අපේ. වෙන මොකුත් table නැහැ. Right. So it has the student or student name, course name, and which instructor is assigned to for that student for that course. Say student is S1, course is course 1, instructor is instructor 1. Say then student 2, say again course 1, maybe the same instructor 1. Maybe student 3 for course 2, maybe instructor 2. Maybe student 3, course 2, maybe again instructor 1, and so on. And you can clearly see that student ID and course ID combination is the primary key, composite primary key. But a student, a course, second main instructor, assign color. Right. So we have instructors. Instructor 1. අපි මේ individual practical sessions හරි මොන හරි කියලා. ඒකට instructor කෙනෙක්ව assign කරන්න ඕන student. Now what is wrong with this design? Assume this is the only table. Now the issue is, say we have a new instructor. I told you that assume this is the only table, right? There's no other table. No table called student, no table called course, or no table called instructor. Or at least assume maybe you have a table called student and course, but you don't have a table called instructor. If you don't have a separate table called instructor and you rely on only this table to get the instructor details, like instructor's names. Now, if there's an instructor, say new instructor is appointed, but still this instructor is not assigned to a particular student and course, particular student course combination. Now what happens is that instructor details are not anywhere in your database. Right? So the instructor is already there. We have recruited, but we have an instructor. These days, none of the student is assigned to that instructor. Again, you don't have a record now. So therefore, if you need to have the instruction details about the instructor in our database, that instructor must be assigned to a student for a particular course. Otherwise, instructor details are not there. So therefore, this is the bad design, because if that instructor is not assigned to a particular student and course combination, in our database, there's no information about that instructor. You can see that it's a very rare, sort of a very trivial case. So therefore, the idea is don't do like this. So if you want to do this, have a separate table called instructor, where you have the instructor ID, instructor name, and so on. So then of course you can have the instructor ID and make it a foreign key. Foreign key එකක් විදිහට දාන්න. ඒ කියන්නේ වෙන table එකක දාලා foreign key එකට connect කරන්න ඕනේ ඒවා මේ table එකේ තියාගන්න එපා. ඒකට වෙනම table එකක් තියෙනවා. ඔයා වෙන table එක දාන්න නැතුව ඒකේ details ගන්න මේක අස්සේ දාන්න. So that is bad. That is bad. So therefore, this has violated the third normal form. If you have only this table, the solution is let's have an instructor table. Then, even if that particular new instructor is not assigned to a student course combination, still the instructor record will be. We can add the instructor record into the instructor table. And here we have just a foreign key, instructor ID. Okay. So anyway, it's obvious. It's a valid scenario. Valid scenario means it's a valid issue. So the solution is you create a separate table. Don't rely on this table to keep track of instructors. Right. So this is what you are supposed to do is have a separate table and have the foreign key. So I hope now you get reasonable understanding about the boycott normal form. ඒක තමයි මේ පොඩ ලස්සන විදිහට කිව්වේ. Each attribute must represent a fact about the key. මේක තියෙනවනේ මේ key එක සම්බන්ධ fact එකක්. මේ instructor කියන්නේ key එක සම්බන්ධ fact එකක් නෙමෙයි අතර. The whole key. ඒක whole key එකට සම්බන්ධ වෙන්නත් ඕන. Nothing but the key. මේක මේ වෙන පුටපට ඒවා මෙතන දාන්න එපා වෙන. හරි. ඒ කියන්නේ ඔයා ස්ටඩි කරන තැන ඔයා වෙන ස්ටඩි වලට අදාළ නැති දෙයක් ගැන තියාගන්න එපා කියලා. ඔය එක දෙකක් තමයි කියන්නේ. ඒක එතන තියෙන්න ඕනේ එතන තියන්න. මෙතන තියන්න එපා. මෙතන ඕනේ නැහැ. හරි ඔයා කන බොන තැන කෑම මේසෙ උඩ ඔයාගෙන ඉන්න මේ නේද? වෙන මොන හරි ගෙනල්ලා තියන්න එපා. අයන් එක ගෙනල්ලා තියන්න. ඒක තියෙන නොතන නෙමෙයි. ඒක තියෙන වෙන තැන. Right. So that is what the normal form is. Sorry, that is what BCNF or boycott normal form is. And it is applicable for this kind of very special scenarios where still one can make this kind of mistake. So then when you look at through the BCNF thinking, you can identify that no, this has violated BCNF. Right. So finally we look at denormalization. So remember, one of you rightly mentioned that when you do normalization, we are introducing more and more tables. So when you introduce more and more table, one problem is maybe sometimes if you don't do it properly, you need more storage. Actually, most of the time you don't need more storage. But there are rare situations you need more storage. But the biggest issue is not more storage or more tables. The biggest issue is when you write queries. Right? When you write queries, when you have data in multiple tables, the query performance decreases because these tables are in different files. Now your database needs to access this file, that file, other file, and join them. So because you want to make it normalized, you have more tables. But more tables means more files access. Rather than you access 1 or 2 files, now to get some data, you need to access 5 files. And so many joins. So sometimes it can be an issue, performance issue. Of course, having multiple tables is not a bad thing because that is the proper design. But if performance issue is so big, sometimes what we can do is we can do denormalization. That means we can take a field and again keep it in. So for example, here. For here. So having supplier name is bad. So having supplier name here is bad because it has violated second normal form. But sometimes designer might decide, yes, it is bad, but we will keep that here also. But anyway, supplier name is in the supplier table also. So don't worry, your supply name is in the supply table also. While you keep it in the supply table, you keep it in the purchase order table also. So that means it duplicate. Because same supply name is in two places now. It has basically violated second normal form also, but still you keep it because most of the time when you query your database, whenever you need purchase order details, you need the supply name for reports and everywhere. So therefore you feel like rather than take these details from two tables by joining, now if I supply name is in my this table itself, that means in the same file supply name is there. So query is going to be faster. So mainly for performance reason, sometimes you duplicate fields like this. But remember, duplicating field is bad idea because you can get into some data issues. Two places that say you change the supply name in one place, you forget to update it the other place. So there can be some issues, but if you know these consequences and still you do it with some purpose, we call it denormalization. Right? Denormalization. That is for a purpose, we violate the normalization. We make some data duplicate. So that is called denormalization. So that must be done for reasons, right? Knowing the consequences. Okay. Right. So now we are done with normalization. So remember, I skip one small part. That is lossless or lossy decomposition. So that we will do next time when we do database. And also we need to do how to design inheritance. There are three approaches that also we'll do in the next class, next time. So then we will start relational algebra, which is very small topic. So then we'll do SQL and views and security, and syllabus is over. දැන් අර කතන්දර ටික ඔලුවට දාලා ඉවරයි. යා තියරි ටික. ඉතුරු ටික ලේසි. ඉතුරු ටික වේගෙන් කරන්න පුළුවන්. SQL එහෙම නිකන් දවසෙන් උනත් කරන්න පුළුවන්. SQL දවසක් කරන්න පුළුවන්. ඇත්තටම FIT වගේ ස්ටුඩන්ට්ලට A level ICT ස්ටුඩන්ට්ලට මම සමානලට දවසෙන් කරනවා. උපරිම දවස් දෙකයි. ඒගොල්ලෝ පොඩි අයනේ. A level ICT ස්ටුඩන්ට්ලයින් ඒගොල්ලෝ පොඩි අය නෙමෙයි. ඒගොල්ලෝ කොහොමද දවසෙන් කරන්න පුළුවන් ඔක්කොම ටික SQL. Right. Full මේ වගේ full class එකක් ගත්තා. Right. We'll stop at this point, right? Thank you.